Hello everyone, welcome to this video. This video is regarding CSAT mathematics. So this video is mainly to build the confidence among the aspirants who have a little fear and face difficulty in dealing with the mathematics part of CSAT. So at the outset I want to tell that this video is my first video in which I am teaching something. So I request you all to excuse me in case of any minor lacunae in video making. So this is about me. My name is Sreenivas Teja and I have secured All India Rank 1 in SSC CGL 2019, and this is my score 724.36 out of 700, and this is mainly due to normalization process, and I have scored 200 out of 200 in Tier 2 paper of mathematics. So this Tier 2 paper, the mathematics paper of Tier 2 in CGLE is more or less on the similar lines of CSAT mathematics. With regard to toughness and types of questions being asked, etc. So why this video? So as I told, this video is for the last minute revision of some important topics which were asked in CSAT, and I will be covering the important models of questions from previous year's papers of various exams, including CSAT, CGL and CHSL, etc. So you will be getting conceptual clarity for a few topics after watching this video, and these will be the topics at large. So the first topic will be number system and HCF, LCM. This is one of the important topics with in mathematics for CSAT paper, mainly because this topic is relatively tougher, and also the weightage of questions, the weightage of marks coming from this topic is relatively high in the last few years. And the second topic will be averages, and third percentages and ratio, and fourth will be clocks. I will cover this topic in first video and these three in second video. So before I move to subject, I want to again make it clear that this is not a complete course video, so you might find some concepts missing. So in this video I will be covering the concepts and models which I felt are important and which we can expect to come in the exam. So this is based on my analysis of previous year's papers, and also this video is like a revision video for you, and I also expect that you are aware about the basics of these topics. So now let's start with the mathematics part. Okay, so number systems. So in these number systems, first we have to know about the natural numbers. What are natural numbers? So beginning from 1, 2, 3, 4. So these are called natural numbers. So there are some important formulas with regard to natural numbers, like sum of n natural numbers, like 1 to n. So is equal to n into n plus 1 by 2. So and next it is sum of squares of n natural numbers is equal to n into n plus 1 into 2n plus 1 by 6. Means this is like sum of squares means 1, 2 square 4, 9, 16, like this. So sum of like up to n. So the sum of squares of n natural numbers is this, n into n plus 1 into 2n plus 1 by 6. So next is sum of cubes of n natural numbers, like 1, so 2 cube is 8, 9, 3 cube is 27, like that, dash 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 n cube. So the formula is n square into n plus 1 whole square by 4. So this is basically the square of sum of n natural numbers, if you see. So next is whole numbers. So whole numbers is nothing but 0 and natural numbers like 0, 1, 2, 3, dash dash dash. So in natural number starts from 1, whole number starts from 0. Next is integers. So in integers like starts from minus infinity to, so minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3 to infinity. So these are from 0, it is called, these are non-negative integers. Non-negative integers, and these are negative integers. So so in this we can divide even on even integers and odd integers. So I think you must know the even integers means like minus 6, minus 4, minus 2, 0, 2, 4 like that, and odd integers means like minus 5, minus 3, minus 1, 1, 2, 3, dash dash dash. The number system is, numbers are basically divided into real numbers and imaginary numbers. So in these real numbers, real numbers is further divided into rational and irrational. So the natural numbers, whole numbers, integers, everything comes under the umbrella of rational numbers. So broadly, these rational numbers also divided into terminating and non-terminating. So this terminating means like 0.5, 0.6. These are terminating rational numbers. Non-terminating means the things which repeats. Like if you take 1 by 3, it is 0.333. This 3 repeats like that. So for example, if you take 1 by 11, here you can see it is like 0.0909. So this thing repeats. This 09 repeats. So this is called non-terminating but recurring recurring numbers. So irrational numbers where the pattern of repetition is not recurring. Like if you see under root 2, it is 1.414 like this, and under root 3 is 1.732. So which the pattern of and it continues, so it doesn't terminates. So and this pattern is also non-recurring. So and imaginary numbers means like under root of -1, under root of -2 like this. So these are imaginary numbers. So what are the prime numbers? So prime numbers are such numbers which have only one and itself as factors. So for example, if you take 2, 3, 5, etc., for these numbers there will be only two factors, which is 1 and the number itself, 2 or 3 or 5, whatever the number is. So so below 100, like 1 to 100, there will be 25 prime numbers. So this thing you better remember. And what are the composite numbers? So the composite numbers are those which are not prime numbers, like which have factors other than 1 and itself. Like for example, if you take 4, 6, 9, etc. So this for these 4, 1, 2 and 4 are the factors. So 1 and other than itself, there is another factor 2. For 6, it is 1, 2, 3, 6. So like for other than 1 and the number itself, there are other two factors. So these are called composite numbers. So there is one more concept called co-primes. So co-primes are two numbers which have just one as a common factor. So for example, if you take 25 and 16, so for this the factors are 1, 5 and 25. So for this the factors are 1, 2, 4, 8 and 16. So if you see among these, the only common factor is 1. So these two are called co-primes. The co-primes the co-primes are those two numbers which have only one as a common factor. So now let's see the divisibility rules. So what is the rule of divisible by 2? So a number is divisible by 2 if the unit digit is even number. That is, the unit digit is divisible by 2. So for example, let's say 214. So the unit digit is 4, which is divisible by 2. So this number is divisible by 2. So if you take 277 here, 277, so the unit digit 7 is not divisible by 2. So this 277 is not divisible by 2, like this. So if the unit digit is 0, either 0, 2, 4, 6 or 8, then the number is divisible by 2. So when what is the rule of divisible by 3? So the sum of digits should be divisible by 3. Sum of digits should be divisible by 3. For example, let's take 6312. So what is the sum of digits? 6 plus 3 9, 9 plus 1 10, 12. So 12 is divisible by 3, right? 3 into 4. So this number is divisible by 3. So for example, if you take number 6317, so here see, 6 plus 3 9, 10 plus 7 17. So this 17 is not divisible by 3. So this number 6317 is not divisible by 3. So next is divisible by 4. So divisible by 4. What is the rule of divisible by 4? So the last two digits of the number should be divisible by 4. Should be divisible by 4. Then the whole number is divisible by 4. So for example, if we take 1864. So in this, what are the last two digits? 64. So this 64 is 16 into 4. So 64 is divisible by 4. So this whole 1864 is divisible by 4. So for example, if we take 2017. So here the last two digits is 17, which is not divisible by 4. Then this whole 2017 is not divisible by 4. So next, divisible by 5. So a number is divisible by 5 if the unit digit, last digit is either 0 or 5. So for example, let's take a number 1955. So here the unit digit is 5. So this number is divisible by 5. If we take now 2020. So the unit digit is 0. So this is also divisible by 5. But for example, if you take number 19731, here the unit digit is 1. So this number is not divisible by 5. So next, divisible by 6. So a number is divisible by 6 if it is divisible by both 2 and 3. That means as I already told, a number is divisible by 2 if the unit digit is a even number, and a number is divisible by 3 if the sum of digits is a multiple of 3. So if both of these conditions satisfies, then a number is divisible by 6. So for example, let's take a number 7290. So this number, see the unit digit is 0, so this is divisible by 2, and the sum of digits 7 plus 2 9, 9 plus 9 18. So 18 is a multiple of 3. So this number is divisible by both 2 and 3, hence this number is divisible by 6. So next, divisible by 7. So this is very important actually. This is a little tough to remember, but you try to remember. So for example, let's take this number and try to understand. So the number is 319,828 and 376. So starting from here, we have to divide the number into 3 digits groups. Like for example, see this last 3 digits is one group, this next 3 digits is one group, next 3 digits is one group. So if there is only 2 digits, then only 2 digits become a group. Like from the right side, we have to make 3 digits one group. So now add this and this, 376 plus 319. So what is this? Sum 1595. So 695. So from this we have to remove this. Subtract this. So minus 828. So what is the value? We get minus 133. So we have to take absolute value, like it is 133. So if this number is divisible by 7, then this whole number is divisible by 7. So as you can see, 19 into 7 is 133. So this 133 is divisible by 7. So this whole number is divisible by 7. So let's take one more example to understand it better. So for example, take this number 25 618 929. So this is a 8-digit number. So we have to divide the number into groups of 3 digits, like from starting from the right. So this is 1, this is 1, and this is 1. So now this alternate we have to add 929 plus 25. So how much we'll get? 954 minus 618. So we have to take absolute of the absolute means positive value. So what is the resultant thing? So 6 3 3. So let's see whether this 336 is divisible by 7 or not. So 336 7 4 ja 28 56 7 8 ja 56 and the remainder is 0. So this 336 is divisible by 7. So hence this number is divisible by 7. So let's take one more example. 460 686 825. So what we should do? We have to divide the number into 3-digit groups starting from the right. So this is one group, this is one group, and this is one group. So and now we have to add the alternate groups. 825 plus 460. So what will we get? 581285 minus 686. So we'll get 995. So 599. So whether we have to check whether 599 is divisible by 7 or not. 7 8 ja 56, 39, 7 5 ja 35. So the remainder is not 0, it is 4. So this 599 is not divisible by 7. So hence this number is not divisible by 7. I hope it is clear. So next, divisibility by 8. So what is the rule of divisibility by 8? So as you remember, as you have seen, for 2 we have to take last 1 digit. For 4 we are taking last 2 digits. So similarly for 8 we will be taking last 3 digits. So if in a number the last 3 digits, the last 3 digits are divisible by 8, then the number is divisible by 8. So for example, take 95312. So this divisibility rules, it's like we can better understand with examples actually. So so this is the number. So we have to take last 3 digits. So 312. Let's see whether this is divisible by 8 or not. So 8 3 ja 24, 72, 8 9 ja 72. So 0. So this 312 is divisible by 8. So this whole number is divisible by 8. So for example, if we take similarly, if we take 106,345. So last 3 digits we have to consider, right? So this 345, obviously this is an odd number and this is not divisible by 8. So hence it is not divisible by 8. So the rule of divisibility by 8 is we have to take last 3 digits, and if this last the number resulting number is, if the resulting number from the last 3 digits is divisible by 8, then the whole number is divisible by 8. So next is divisibility by 9. So what is the rule of divisibility of 9? So same, if you have seen for 3, the rule is like the sum, if the sum of digits is divisible by 3, then the number is divisible by 3. So similarly for 9, if the sum of digits is divisible by 9, then the whole number is divisible by 9. So for example, take number 547101. So what is the sum of digits? 5 plus 4 9, 9 plus 7 16, 17, 18. So 18. So 18 is divisible by 9, right? 9 into 2. So then this whole number is divisible by 9. So the divisibility by 9, I hope it is clear. So if the sum of digits is divisible by 9, then the whole number is divisible by 9. Next is divisibility by 10. So if the unit digit is 0, then the number is divisible by 10. So similarly for 100, if the last 2 digits of a number is last 2 digits of the number are 0, then the number is divisible by 100. For example, see. So for example, take 6750. So as the unit digit is divisible by as the unit digit is 0, this number is divisible by 10. So similarly, if you take 368700, As the last two digits of this number are 0, this number is divisible by 100. Is divisibility by 11. So this is also again very important, and many problems comes from this concept. So again let's learn it by taking an example. So let's take the number 57490400165. So to check the divisibility by 11, we have to take the difference between the sum of alternate digits. Difference between the sum of alternate digits. I mean, we have to add the digits at even places, and we have to add the digits at odd places, and we have to subtract them. So let's see. It will be clear from the example. So now map the alternate digits. So 5, 1, 4, 9, 7, and starting from even places 0, 0, 4 and 5. So now add the digits at odd places. 5 plus 1 4, 4 plus 4 8, 8 plus 9 17, plus 7 26, minus now even places. 6 plus 0 0, 0 plus 0 0, and 0 plus 4, sorry, 6 plus 4 10, 10 plus 5 15, minus 15. So what is the difference? It is 11. So if this difference is either 0 or a multiple of 11, 11 or 22, like this. I mean, if the difference is either 0 or a multiple of 11, then this number is divisible by 11. So let's take one more example to get more clarity. So let's take one more number, 3329584 So this is a 9-digit number. Now map the digits at odd places. 0, 8, 9 and 3. So now map the digits at even places. 2, 4, 5, 2. So now the sum of digits at odd places. 7 plus 0, 0, 0 plus 8, 15, 15 plus 9, 24, 24 plus 3, 27, minus sum of digits at even places. 2 plus 4, 6, 6 plus 5, 11, 11 plus 2, 13. So the difference is 14. So this is not equal to 0, or either it is not a multiple of 11. So hence this number is not divisible by 11. So let's take one more example, 6250343. So what we have to do, first we have to map the digits at odd places, 3, 5 and 6. Next, even places. So what is the sum of digits at even odd places? 3 plus 3 6, 6 plus 5 11, 11 plus 6 17. Next, 4 plus 0 4 plus 2 6, minus 6. So this difference is 11. So hence this number is divisible by 11. I hope it is clear. Next, divisible by 12. So same with 6. If a number is divisible by both 3 and 4, then it is divisible by 12. As you know, if a number is divisible by 3, then the sum of digits is a multiple of 3. And if a number has to be divisible by 4, then the last two digits of the number must be divisible by 4. So if the both conditions satisfy, then the number is divisible by 12. So for example, take 68196. So first check the divisibility by 3. So what is the sum of digits here? 6 plus 8 14, 14 plus 10 24 plus 6 30. So 30 is a multiple of 3, hence it is divisible by 3. Next we have to check divisibility by 4. Take last two digits. Last two digits is 96. So clearly 96 is 24 into 4. So this number is divisible by 4. So this number is divisible by both 3 and 4. Hence this number is divisible by 12. So similarly, divisibility by 15. So a number is divisible by 15 if it is divisible both by 3 and 5, same as 12. So a number is divisible by 3 when the sum of digits is divisible by 3, is a multiple of 3. And a number is divisible by 5 if the last unit digit is either 0 or 5. So for example, take the number 84735. So whether it is divisible by 15 or not. First check whether it is divisible by 3 or not. So what is the sum of digits here? 8 plus 4 12, 12 plus 7 19, 19 plus 3 22, 22 plus 5 27. So 27 is a multiple of 3, right? 9 into 3. So hence this is divisible by 3, and as the last digit is 5, this whole number is divisible by 5. So when a number is divisible by both 3 and 5, it is divisible by 15. Then divisibility by 16. So if you remember, we discussed that a number is divisible by 2 if the unit digit is a even number, or if the unit digit is divisible by 2. A number is divisible by 4 if the last two digits are divisible by 4. A number is divisible by 8 if the last three digits is divisible by 8. Similarly, a number is divisible by 16 if the last four digits. For 16, last four digits must be divisible by 4. So for example, take the number 1 3 8 2 7 7 9 2. So we have to check whether this number is divisible by 16 or not. So take last four digits. So the last four digits is 77 92, and check whether this is divisible by 16 or not. So 16 4 ja 64, 139. So 16 8 ja 128, 1112, and 16 7 ja 1112. So it is 0, remainder is 0. So hence this 7792 is divisible by 16. So then this whole number 13827792 is divisible by 16. So I'll tell again. So for a number to be divisible by 2, the last digit must be divisible by 2. For a number to be divisible by 4, the last two digits must be a multiple of 4. That is, the last two digits must be divisible by 4. Similarly, for a number to be divisible by 8, last three digits, this should be a multiple of 8. Similarly, for a number to be divisible by 16, last four digits must be a multiple of 16. I mean, the last four digits must be divisible by 16. So next these things you have to remember. These are very important. Divisible by 101. So a number in form AB. For example, say 37. So this is divisible by 101 for sure. For example, take one more number, 23. So it is in the form of AB, like digits are repeating, right? AB. So this is divisible by 101. Next is divisible by 101. So this is a very important concept. 1001. So this 1001 is a multiplication of three prime numbers, 7 into 11 into 13. If we see 13 sevens are 91. So 91 into 11 means 91. 1, 10. So this 1001 is a multiplication of three prime numbers, 7, 11 and 13. So any number in the form ABC is divisible by 1001. So any number in the form ABC is divisible by 1001, and in turn it is divisible by 7, 11 and 13. So for example, let's take number 542. So this is in the form of ABC. So this is divisible by 7 and 11 and 13. Next is divisibility by 111. So any number in the form like repeating three times, like A, like 6 times, right? Or 9 times. So this is divisible by 111. So this 111 is a product of two prime numbers. This is also very important. 37 into 3. So any number which is a multiple of 111 is also a multiple of 37. I mean, to tell again, this 111 is a product of two prime numbers, 3 into 37. So any number which is divisible by 111 is also divisible by 37. This we have to remember. And any number in the form this time, like A means like repeating 3 times or 6 times or 9 times or 12 times, multiple of 3, is divisible by 111. Okay, so next concept is when the number is in form of a power n plus b power n, where n is odd, So then this is divisible by a plus b, means a plus b is factor of a power n plus b power n when n is odd. So for example, let's say 25 power 17 plus uh, plus 31 power 17. So this is in the form of a power n plus b power n, where n 17 is an odd number. So then this is divisible by 25 plus 31 is a plus b, which is 56. So which in turn is divisible by 28, like that, like 56, 28 and 14, everything is factor of this thing. So when the number is in form of a power n plus b power n and n is odd, then it is divisible by a plus b. This much you remember. So when it is in the form of a power n minus b power n and n is odd, so n is odd, then this is divisible by a minus b. See, for example, let's say same. So 25 power 17 minus, okay, minus 13 power 17. Let's consider the number 25 power 17 minus 13 by 17. So this is in the form of a power n minus b power n, right? So then this is divisible by 25 minus 13, that is 12. So 12 is a factor of this number. So when it is in the form of same a power n plus b power n, and when n is even, then a power n minus b power n is divisible both by a plus b and a minus b. So I will tell again. So when the number is in form of a power n minus b power n, where n is an even number, then it is divisible by both a plus b and a minus b. So when if n is odd, it is only divisible by a minus b. But when n is even, it is divisible by a plus b and a minus b. So for example, let's consider 31 power 4 minus 17 power 4. So this is in the form of a power n minus b power n, where n 4 is a even number. So then this is divisible both by 31 plus 7, 48, and 31 minus 17, 14. So both 14 and 48 are factors of this 31 power 4 minus 17 power 4. So next concept is number of factors. So so first, for this we have to know how to factorize any number. So for example, let's say there is a number 720. So 720 is there. How to factorize this? So so factorization means we have to write in the terms of powers of prime numbers. Powers of prime numbers, like 2. So we have to write this in the form of 2 power a into 3 power b into 5 power c into 7 power d, like this. So this is called factorization. So factorizing means we have to write any number in terms of powers of prime numbers. So let's take 720. How to factorize it? So 720. So first we have to divide it by 2. So 2 means 360, right? Next again 2, 180. Then again to 90. Then again to 45. So now it won't go with 2, right? So then you have to take 3, 15. So again it will not, it will go with 3, right? 3 into 5. So now we have to write it in this form. So how many times 2 is coming? 2, 1, 2, 3, 4. Therefore 720 is equal to 2 power 4 into, so how many times 3 is coming? 3 power 2 into 5 power 1. 5 is coming 1 time. So let's do it, do the same for another number. So for example, let's take 840. So let's do the same with 840. So so 840 to 420, again to it will go 210, again to it will go 105. So now it won't go with 2. So let's try 3, 35. So now 5 7s are. So how will you write 840 in terms of prime numbers, I mean factorization? So 2 power 1, 2, 3. 2 power 3 into 3 power 1 into 5 power 1 into 7 power 1. So this is the way how we do factorization. So next, so number of factors. So for example, okay, so let a number is written in the form of n is equal to 2 power a into 3 power b into 5 power c into 7 power d dash dash, like the so a number is written in the terms of powers of prime, product of powers of prime numbers. So what will be the number of factors of this number? So then the number of factors is equal to a plus 1 into b plus 1 into c plus 1 into d plus 1 dash dash. So let's say if the number is only till here, then it will stop here. If there is 11 power e, next prime number is 11, right? If it is 11 power e, then here we have to write, we have to multiply with e plus 1 to find out total number of factors. This is total number of factors. So next is if the same number which is in the form of 2 power a into 3 power b into 5 power c into 7 power d dash dash. So we have given the formula for number of factors. Now it is number of even factors. So the factors which are even, so number of even factors is equal to a. Here we are not taking a plus 1, here only we are taking a into b plus 1 into c plus 1 into d plus 1 dash dash. So next, number of odd factors. So that means the factors which are odd numbers. So it will come b plus 1 into c plus 1 into d plus 1 dash dash. So if we add both of these, so it will be total number of factors anyway. So if you can verify it from here, it will be like, so you can take this and this as common, so a plus 1 will be left out. So a plus 1 into again b plus 1 c plus 1 d plus 1 dash dash. So this is the formula for total number of factors, and this is the formula for number of even factors. I mean the factors which are even, a into b plus 1 into c plus 1 into d plus 1 dash dash. So the formula for number of odd factors is b plus 1 into c plus 1 into d plus 1 dash dash. So next is factors which are prime numbers. So number of factors which are prime numbers. This is simple. It is just a plus b plus c plus d dash dash. So this is the formula for number of factors which are prime numbers, a plus b plus c plus d. So next is sum of factors. So the sum of factors is see, let for example the number is in the form of 2 power a into 3 power b into 5 power c into 7 power d, like this. So for this, what will be the sum of factors? Sum of factors, it will be 2 power 0 plus 2 power 1 dash 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 till 2 plus 2 power a into 3 power 0 plus 3 power 1 plus dash 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 till 3 power b into 5 power 0 plus 5 power 1 plus dash 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 till 5 power c, like that, like this it will continue. So we'll take one example and find out the sum of factors for your clarity. So we will take the same example of 720 to find out the sum of factors. So how did we write 720? 2 power 4 into 3 power 2 into 5 power 1, right? So 720 can be written as 2 power 4 into 3 power 2 into 5 power 1. So for this we have to find the sum of factors. So as we discussed, the formula goes 2 power 0 plus 2 power 1 dash 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 2 power a into 3 power 0 plus 3 power 1 plus dash 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 3 power b into 5 power 0 plus 5 power 1 dash 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 5 power c. It goes like this. So the sum of factors is, so 2 power 0 plus 2 power 1 plus 2 power 2 plus 2 power 3 plus a is equal to 4 here, 2 power 4 into 3 power 0 plus 3 power 1 plus 3 power 2 into 5 power 0 plus 5 power 1. So here 2 power 0 is 1, 1 plus 2, 3, 3 plus 2 square is 4, 7, 7 plus 2 cube is 8, 7 plus 8, 15, 15 plus 16, 31 into 3 power 0, 1, 1 plus 3, 4, 4 plus 9, 13 into 5 power 0, 1 plus 5, 6. So 31 into uh, 78 into 31, 78 to 34, 8, 11. So what is the sum of factors, sum of factors for 720? It is 2418. It should be find out like this. I hope it is clear. See, let's revise the formulas again. See, when the number is written in this form after factorizing, what is the formula for total number of factors? This is a plus 1 into b plus 1 plus into c plus 1 into d plus 1 dash dash. So what is the formula for total number of even factors? It is we have to take only a here for 2. So a into b plus 1 into c plus 1 into d plus 1 dash dash dash. So total number of odd factors, it is b plus 1 into c plus 1 into d plus 1 dash dash. So next is number of factors which are prime numbers, prime factors, or we can say number of prime factors. It is a plus b plus c plus d dash dash. Then so next is perfect square factors. So let's go to other page. So okay, so for example, this is our number. We have to find out the number of factors which are perfect squares, which are perfect squares. So what are perfect squares? See, for example, 4, 9, 16, 25. These are perfect squares. Like 4 is 2 square, 3 square, 4 square, 5 square. So number of such factors which are perfect squares. For this, what is the formula? So let this is in the form of 2 power a into 3 power b into 5 power c into 7 power d dash dash dash. Then the number of factors which are perfect squares goes like this: a by 2 plus 1 into b by 2 plus 1, c by 2 plus 1 into d by 2 plus 1 dash dash dash. So how should we take a by 2? See, for example, let's take this example. Let's take this number where n is equal to 2 power 13 into 3 power 9 into 5 power 6 into 7 power 5. So here a is 13, right? So in a power 2, it is not, this is not divisible by 2. So we have to take the quotient, like 13 by 2 is 6, 1. So we have to take 6. See, for example, the 13 by 2 falls between 6 and 7, right? So here we have to take 6. So for like this, let's find out the number of perfect squares for this number. So 13 by 2, so 6 plus 1, we have to take the lower integer. So b is 9. So 9 by 2 is 9 by 2 falls between 4 and 5, right? 4.5. So 4 plus 1 into c by 2. C is 6. So c by 2 is 3. 3 plus 1 into d by 2 is 5 by 2, which falls between 2 and 3. So 2 plus 1. So 7 into 5, 35. 35 into 4. So 7 into 5 into 4 into 3. So 7 5 are 35. 35 into 3, 105 into 4, 420. So number of factors which are perfect squares for this number is 420. So I hope you understand this concept. I will tell again. See, let's say the number is in the form of like this. So 2 power a into 3 power b into 5 power 6 into 7 power d. So now we have to find out number of factors which are perfect squares. So these are the perfect squares, like 1, 4, 9, 16, 25, which like 4 is 2 square, 9 is 3 square, 16 is 4 square. So these are called perfect squares. So for this, the formula will be like this: a by 2 plus 1 into b by 2 plus 1 into c by 2 plus 1 into d by 2 plus 1. So for this, how we have to take? See, let's take this example. N is equal to 2 power 13 into 3 power 9 into 5 power 6 into 7 power 5. Here a by 2 is, here like 13 is not divisible by 2. but 13 by 2 falls between 6 and 7. So when this happens, we have to take the lower boundary like 6. So a by 2 here becomes 6 plus 1 into b by 2 is b is 9, right? So 9 by 2 falls between 4 and 5. So 4 plus 1 into c by 2, c is 6. So there is no problem. 3 plus 1 into d by 2, d is 5. So 5 by 2 falls between 2 and 3. So 2 into 3. So here 7 into 5 into 4 into 3. So number of factors which are perfect square for this number is 420. Like this we have to find out. So like in the same way, we have to find out the number of factors which are perfect cubes. So what are perfect cubes? So same 1, 2 cube is 8, 3 cube 27, 4 cube 64, 5 cube 125. So these are the perfect cubes. So number of such factors which are number of factors of this which are perfect cubes like this. We have to find out the number of factors which are perfect cubes. So for this the formula will be a by 3 plus 1 into b by 3 plus 1 into c by 3 plus 1 into d by 3 plus 1 dash dash. So how we will find out? Let's take the same case. So here a is 13. So 13 by 3. It falls between 3 4s are 12 and 3 5s are 15. It falls between 4 and 5, right? So we have to take 4. So here 4 plus 1 into, so b by 3, b is 9. So 9 by 3 is direct 3. So 3 plus 1 into, so c is 6, right? 6 by 3 is 2 plus 1 into d is 5. So 5 by 3 falls between 3 1 is 3, 3 2 is 6. So 3 to 6, right? So you have to take 1 plus 1. So here 5 into 4, 20, 20 into 3, 60, 60 into 2, 120. So number of factors which are perfect cubes for this number is 120. So let's see this concept again. So this is very important. So let's assume the number is this is our number. So this is in this form, right? 2 power a into 3 power b into 5 power c into 7 power d. So we have to find out number of factors which are perfect cubes. So what are the perfect cubes? Perfect cubes are like this: 1, 8, 27, 64, 125. So 8 is 2 cube. So 27 is 3 cube. So 64 is 4 cube. So these are called perfect cubes. So what is the formula for total number of factors which are perfect cubes? It goes like this: a by 3 plus 1 into b by 3 plus 1 into c by 3 plus 1 into d by 3 plus 1. So how should we take? So if so here a is 13, right? So 13 by 3. So 13 is not divisible by 3. So but it falls between 4 and 5. So we have to take 4. So 4 plus 1 into, so b plus 3, b is 9. It is divisible by 3. So 3 plus 1, c is 6. It is also divisible by 3. 2 plus 1 into d is 5. So 5 falls between 1 and 2. So 1 into 1. So this whole multiplication is 120. So number of factors which are perfect cubes is 120. So the next concept is number of zeros. So we have to find out how many zeros are there at the end of this product. So whenever there is a product like this, so first we have to find out number of 2's and number of 5's in this product. See, for example, if you see this product, see, for example, if in this product there are 4 5's and 4 2's and 3 5's. So then the minimum number is, like 5's are in minimum, so 3. So whenever there is a 2 and 5, so the product becomes 10, right? So when there are 3 5's and obviously 3 2's are there, means there will be 3 zeros. So here when there is 1 2 and 1 5, the product will be 10, which means there will be 1 0. So how many times the 2 and 5 repeats, that many number of zeros will be there in a product. So you will get clarity when we solve the problems. So for example, see here, when there are 4 2's and 3 5's in a product, then the number of zeros will be the whichever is smaller, means number of zeros will be 3. So let's find out number of zeros in this. See here it is 5 into 10 into 15 into 20, like this it will go, right? So so first we find out number of 2's. So in 10 how many 2's will be there? 2 into 5, 1. In 20 is 4 into 5, right? So here this is 2 into 2. So in 20 there will be 2 2's, not 1. In 20 it will be 2 2's because 20 has 4 as a factor. 4 means 2 square. So next is 30. In 30 how many 2's will be there? Only 1. 2 into 15. So 1. Next is 40. Again 40 is 8 into 5, right? So 8 is 2 cube. So 3 2's will be there. Next next it is 50. So again 50 is 2 into 5, right? So 1 2 will be there. So next is 60. 60 is 4 into 15. So 2 2's will be there. 2 square. 4 is 2 square, right? Now next is finally 70. 70 is 2 into 35. So only 1 2. So how many number of 2's are there? 1 plus 2 3, 3 plus 1 4, 4 plus 3 7, 7 plus 1 8, 8 plus 3 11. So total number of 2's are 11. So now we will find out number of 5's. So what will be number of 5's? So 5. In 5 1. So next 1 plus 2 into 5, again 1 plus next 3 into 5, 1 plus. So we can see that 14 into 5. So there will be 14 5's, but in between if you see 25 will be there. So 25 is 5 square, right? So plus 1 more 5. Again 50 will be there. 50 is 2 into 5 square. So again 1 5 extra will come in 50. So total how many 5's will be there? 16. So if you see in this product there will be total 13 2's here, total 11 2's and 16 5's. So how many zeros will be there in this product? Minimum of these. So 11 zeros will be there. So I'll again explain the concept. I know it is a little complex. So we have to find out number of zeros at the end of a product like this. So when a zero will be there, so if we have 1 2 and 1 5 in a product, the product will be 2 5s are 10. So whatever the minimum number of 2's and 5's, whichever is smaller, like if we have 4 2's and 3 5's, the minimum number is 3, right? So there will be 3 zeros at the end of this product. So in order to find out number of zeros at the end of the product, we have to find out number of 2's and number of 5's, and whatever is the minimum among them, that will be the number of zeros. So we have to find out first number of 2's in this product. So in this product, if we see 5 into 10 into 15 into 20, it will go like this. So how many are there? Obviously 2 will be there only in a even number. So we can see 10, 20, 30, 40, 50, 60 and 70. So this 20 is 2 into 5. So only 1 2. But this 20 is 10 is 2 into 5, only 1. This 20 is 4 into 5. So 4 is 2 square, right? So there will be 2 2's in 20. Again 30 is 2 into 15, 1 2. But 40 is 8 into 5. So 2 cube into 5. So there will be 3 2's. 50 is again 2 into 25. So there will be 1 2. 60 is 4 into 15. Again 2 2's. 70 is 2 into 35, 1 2. So what is the total? 1 2 1 3 4 7 8 10 11. So there will be total 11 2's in this product. So now we have to similar way we have to find out 5's. So obviously 5 1s are 5, 5 2s are 10, 5 3s are 15. Like that 14 5s are 70, right? So first 14. But in between there will be a 25, which is 5 square. So in this 14 already we counted 1 5. So plus 1 extra 5 for 25. And this 1 extra 5 there will be 50, right? 50 is also 25 into 2. So there will be 2 5's. So 1. So total number of 5's is 16. So which is minimum? Here 2's are 11, 5's are 16. So there will be total number of 11 zeros in this product. So in this way we have to find out. So next we will take this example. It will be more clear for you. So let's consider the product 1 into 2 into 3 into dash 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 into 1196. We should find out number of zeros at the end of this product. So as I told, minimum like 2's and 5's, number of 2's and 5's we have to find out, and the minimum of them will be the number of zeros. Whatever is the lower number of, like we have to find out number of 2's and number of 5's. Whichever is lower will be the number of zeros. So obviously if you see here, there will be 2 after every one, like 2, 4, 6, 8, there will be 2 after every other number. So obviously common sense tells us that in this multiplication, in this product, 2's will be in majority, because after every other number 2's will come. So for this we have to find out number of 5's. So number of 5's will be our number of zeros in this product. I am talking about this case. So how will we find out number of 5's? So now we can't count like 5, 10, 15. So till 1196 it is very difficult to count the number of 5's, right? So how we'll do? So just take 1196 and divide it with 5. So what will be the quotient? 2, 3, 15 plus 9, it is 1. So take 239. So again divide this 239 with 5. Means now we see, now we got number of 5's. Now we are trying to find out number of 25's by dividing again it with 5. By dividing the quotient again with 5, we are finding number of 25's, because we have to add one more 5. Like how many number of 25's are there? Such like how many number of 25's are there, that number of 5's will be added to this. So 5 divided by 239, how it will come? Like 5 4s are 20, 39, 5 7s are 35, so 4. So now it doesn't go, right? So 47. Next again now we are looking for 125, like 25 into 5, 125. In this 125 in these factors of 125 also will be there, right? So what will we do? Again divide 47 with 5. So 5 9s are 45. So 2 will be our this thing, right? So there will be, so add this 9 here. So again divide the 9 with 5, because in this if you see, there will be 625 will be also there, which is 5 power 4. Means in 625 there will be 4 5's. So this is 5 1s are 5, 4. So 6 1. So if we add these things, 9 plus 1 10, 10 plus 16 26, and 9 296. So total 296 5's will be there, and 2's will be obviously more, because for after every other number 2 will 1 2 will come. So number of zeros in this product will be 296. So this is how we do. So I will again explain the concept. So we have to find out the number of zeros at the end of this product. Okay, 1 into 2 into 3 till 1196. So as I explained, for 1 2 and 1 5 in a product, there will be 1 0. So we have to count number of 2's and number of 5's, and the minimum of which will be our number of zeros. So here the 2 will in, so this is a big product, so the 2 will be there after every number, like this, and it is very difficult for us to count the 5's. So in this in this particular question we will do like this. So we have to divide the last, this 1196 with 5. So the quotient will come 239. So number of 5's 239, but there will be 25's also in the product, which will give us one more 5, right? So we have to divide again this 239 with 5 to get number of 25's. So this is number of 25's, this quotient. So there will be 125's also in this product, which is 5 cube. 5 cube means one more 5 will be there. So this 47 by 5. So the quotient is 9. So this is 9, and we have to divide again 9 with 5, which gives 1, which means it accounts for 625, which is 5 power 4. In this there will be 4 5's. So if we add all of this, we will get 296. So there will be 296 5's, and 2's will be obviously more than 296. So number of zeros in this product is 296. I hope it is clear. So next is dividend formula. So this is a basic thing which we all know. What is the dividend formula? So dividend is equal to quotient into divisor plus remainder. So this is the dividend formula. And after that, concepts of successive division. So there will be some questions which states that, see, when a number is divided by 7, 8, when a number is successively divided by 7, 8 and 4, the remainders are 6, 4 and 1. So when respectively. So find out the remainder when the number is divided by 15. So this will be the question. So the question will be like this: when a number is successively divided by 7, 8 and 4, the remainders will be 6, 4 and 1. So then find out the remainder when the same number is divided by 15. So how will we find out? So we will write like this. So number is successively divided by 7, 8 and 4, right? So on the remainders we will write like this: 6, 4 and 1. So let us assume that the last quotient is 1. Last quotient is 1. So here 4 into 1 plus remainder 1. What is this? 4 1 is 4 plus 1 5. So we have to write 5 here. So 5, so again 8 into 5 plus this remainder 4. So 8 into 5 40 plus 4 44. 44 plus this remainder 6. So this can be our number. See 7 into 4, 7 into 44 into 7 is 308 plus 6. It is 314. So our number can be 314. There can be many such numbers, but 314 is one number. See, let's just check whether this is correct or not. See, when 314 is divided successively by 784. So when it is divided by 7, what is the remainder? 7, obviously 744 ja 308. So the remainder is 6. So it is correct. This is then the same, it is divided by 8. They are telling successively. Successively means the quotient is again divided by 8. So 8 5 is 40. What is the remainder? 4. So when it this is correct. So when this successively 5 is divided by, next is 4. What is the remainder? 1. So this can be our number. So when the same number is divided by 15, 314 is divided by 15. So what is the remainder? 20 is 300. 14 will be our remainder. So this is the concept of successive division. So I will again explain. So the question can be like this: when a number n is successively divided by 7, 8 and 4, it will give remainders 6, 4, 1 respectively. So what is the remainder when the same number is divided by 15? So how will we solve the concept of successive division? So it is given that the number is successfully divided by 7, 8 and 4. So we'll write like this, and they also told that they yield 6, 4, 1 as remainders respectively. So we'll assume the last quotient as 1. So here the number will be then 4 into 1 plus remainder 1. So it is 4 1 is 4 plus 1 5. So we'll write 5 here. So 8 into 5 plus remainder 4. This 4. So 8 5 is 40 plus 4 44. So into 44 plus remainders this 6. So what will be the number? 308 plus 6 is 314. So this can be our number. This can be any number. Means if we assume the last quotient as 2, then again the number will change. If we assume the last quotient as 0, then the number will change. So I am just telling you this can be the number which when successively divided by 7, 8, 4, the remainders will be 6, 4, 1. So when the same number is divided by 15, what is the remainder? 15 to the 30, 1 4 0 ja. So 14. So 14 will be our remainder. So this is the concept of successive division. So these are the few problems or reminders which will involve some different concepts. Just I'll touch these briefly. So let's see, when they can ask what is the remainder when 2 power 44 is divided by 7. So for this we can go in a pattern method. Like, see, when 2 power n 1 is divided by 7, what is the remainder? 2 power 1 is 2, out of 7 0 0 means 2. So remainder is 2 only. The same way, when 2 square is divided by 7, the remainder will be 4. When 2 cube is divided by 7, 2 cube is 8, right? When 8 is divided by 7, what is the remainder? 1. So 2 power 4 by 7, 16 is divided by 7, what is the remainder? 7 to the 14, so 2 will be remainder. So 2 power 8 is divided by 7, sorry, 2 power 5. So 32 is divided by 7, what is the remainder? 7 4 is 28, it is 4. When 2 power 6 is divided by 7, 64 by 7, 7 9 is 63, 1. So if you see, after 2 power 3, this pattern is getting repeated. Are you getting my point? See, when you see this, After 2 cube, see 2 power 1, 2 power 2, 2 power 3, remainder is 241. Again 4, 5, 6, 2 power 4, 2 power 5, 2 power 6, the remainder is 241. So the same way, what is like 44? 14 into 3 is 42. Right. So the 2 power 42 by 7, the remainder will be again 1 because it is divisible by 3. So for 2 power 43, the remainder will be, 2 power 42, 43, 2 power 43 by 7, the remainder will be 2. So 2 power 44 by 7, the remainder will be 4. So in this way we can solve this. I'll explain this again. See, when the problems are in this form, 2 power n by 7, something like this. See, if we see, let's just establish a pattern here. So when 2 power 1 by 7, the remainder is 2, obviously. So when 2 power 2 by 7, the remainder is 4. 2 power 3 by 7, 8 by 7, the remainder is 1. Then again 2 power 4 by 7, which is 16 by 7, 7 2 is 14, the remainder is 2. When there is 2 power 5 by 7, 2 power 5 is 32, 32 by 7, the remainder is 7 4 is 28, 4. So 2 power 6 by 7 is 64 by 7, the remainder is 1. So after power 3, after the power is multiple of 3, the pattern is getting repeated. Like again the same pattern will repeat for 2 power 7, 8 and 9. So when they are asking like this 2 power 44 by 7, we have to see where this falls. So the 3 multiple near to this is 42, right? So for 2 power 42 by 7, the remainder will be obviously 1. So for 43 by 7, the remainder will be 2. So for 2 power 44 by 7, the remainder will be 4. So we can do like this. Again the same for this, see. So 4 power 1 by 6, what is the remainder? 4. 4 square by 6, so 16 by 6. So 6 2 ja 12, again remainder is 4. So 4 cube by 6 is 64 by 6. So 6 10 ja 60, again 4. So for any power of 4, if it is divided by 6, the remainder is 4 only. So if they ask 4 power 104 by 6, what is the remainder? So you can directly say it is 4 without doing any calculation or anything, just by observing this pattern. I hope it is clear. Okay. So next, similarly, if they ask 9 power n by 16. Okay. So now let's consider this 9 power n by 16. So when n is 1, so similarly, when we consider this 9 power n by 16, so when n is 1, what is the remainder? 9 by 16, remainder is 9. So n is 2 means 9 square by 16, so 81 by 16, 16 5 is 80, so 1. So again n cube, so 9 cube is 729, right, by 16. So the remainder is 9. See 16, 16 4 is 64, 8 0 89, 16 5 is 16 into 45 is 720. So 9 will be the remainder. So again for 9 power 4 by 16, if you see, the remainder will be 1. So after after every 2 in powers, it is getting the pattern is getting repeated. So for see, when you can establish something like this, when it is 9 power n by 16, for odd powers of n, the remainder is 9. For even powers, the remainder is 1. See, for n power, when n is 1, the remainder is 9. When n is 3, the remainder is 9. So when n is odd, the remainder is 9. So when n is even, like 9 square, 9 power 4, the remainder is 1. So if they ask you like this, 9 power say 75 by 16, find out the remainder. So by this pattern you can tell the remainder will be 9. Simple. So similarly with these kind of questions, how can you do? So there is no you can't establish any pattern here when it is with 5. So here what we apply is, see, 3 power 44 by 5, right? So I am telling these are all methods. You can apply any method. Like here we like with these questions we have established a pattern and find out the remainders. Here what you can do, what is the easiest method here is, like we have to convert this into a nearest multiple of 5. Means what is the nearest multiple of 5? It can be 10, right? So you can write like this, 3 square into 22. 44 is 2 into 22 by 5. So what is 3 square? 9 power 22 by 5. So you can write this like this: 10 minus 1 whole power 22 by 5. So when you expand this expression, so last term will be, see, it will be like 10 power 22 plus something into 10 power 21 into 1, sorry, minus 1 plus something into 10 power 20 into minus 1 whole square. It will go like this, and the last term will be minus 1 whole power 22. If you see here, every term will be divided by 5 because 10 is involved. When 10 is involved, every term will be divisible by 5 except this term. So what is this last term? Minus 1 whole power 22 is 1. So it will be like, you can write it like 5 into some kind of some k plus 1. This will be. So what will be our remainder? It will be 1. So I will explain again in simple terms. See, what we did in the last slide is we tried to establish patterns where we can find out the remainder. But with this kind of problem, when it is involved like this, it is easy to apply other method. Like what we have to do is we have to convert this into the nearest multiple of 5. I mean, nearest multiple means the the difference from the multiple should be 1, at max 1. So I will show you how. See, the 3 power 44 by 5, we can write it as 3 power 2 into 22 by 5, right? So what is this 3 power 2? It is 9. 9 power 22 by 5. So again, this 9 power 22 is 10 minus 1 whole power 22 by 5. So if we do this binomial expansion, see, let's say a plus b whole power n is the binomial expansion. So so every term will involve a except the a power n plus nc1 into a power n minus 1 into b. Like this it will come. Only the I mean, for you this formula is not needed. You just remember this thing. Only the last term will be b power n. Okay. So where this a is not involved. See, here the a is 10. Whenever the a is involved, it is divisible by 5, right? 10 is divisible by 5. So every term is divisible by 5 except this last one. So it can be like, you can write 5 into some k plus last term is minus 1 whole power 22, which is 1 by 5. So obviously in this the remainder will be 1. I hope it is clear. So okay, see this question, same. So it is given 2 power 75 by 31. So we have to make it somewhere near 31, right? How can we do that? You can write this like this: 2 power 5 whole power 15 by 31. So what is 2 power 5? It is 32 whole power 15 by 31. So you can write this as 31 plus 1 whole power 15 by 31. So the same, this, if you go by this logic, every term here is divisible by 31 because 31 is involved here, 31 is involved here. So every term is divisible by 31 except last 1 whole power 15. So it can be, so this can be written like this: 31 into some k plus last term is 1 power 15, which is 1 by 31. So what is the remainder here again? So remainder is again 1. So this is the this method is based on the binomial expansion. I hope it is clear. So there is a last concept which I didn't put in the slides, which I remember. It is based on arithmetic progression. So I have seen 1 or 2 questions based on this in the last few years in CSAT. So what is arithmetic progression? So just need to remember some formulas here. So so let us say 2, 5, 8, 11, like this. So this can be our arithmetic progression. See here, 2 plus 3 is 5, 5 plus 3 is 8, 8 plus 3 is 11. So whenever there is a set of numbers like this, sequence of numbers a1, a2, a3, a4, the common difference between two numbers is same. Two successive numbers is same. 2 plus 3, 3 plus 5 plus 3, 8 plus 3, like this. So this sequence is called arithmetic progression. So here the few formulas. So D is common difference. So what is common difference? you can difference between any two successive numbers, like a2 minus a1 is same as a3 minus a2, a4 minus a3 here. So this is called common difference. So next is number of terms in the sequence, n. So for this the formula is last term. So this is last term minus first term by d plus 1. So this is the formula for number of terms in a sequence. So next is nth term. How to find out nth term? When you know the first term and n. Sorry, d. So when you know a and d, a1 and d, a1 is the first term and d is the common difference. How can you find out the nth term? So the formula is a1 plus n minus 1 into d. This will be the formula for nth term. So next is sum of n terms. So total sum of this a1, a2, an, the sum of the arithmetic progression, sum of all these terms. So this is directly n by 2 into a1 plus a1, an. So n by 2 into first term plus last term. If you don't know last term but you know common difference d, if you don't know an but you know d, then it will be n by 2 into 2a1 plus n minus 1 into d. Simple. Here we have this is an, right? This is tn or an. Simple. This an we have substituted this. So this is sum of n terms of arithmetic progression. So if this is the arithmetic progression, then the sum of the terms of this arithmetic progression, the formula is this, n by 2 into a1 plus an, first term plus last term, and it can be written like this, n by 2 into 2a1 plus n minus 1 into d. So now let us start with problems. So before we start with problems, I just want to tell you one thing. See, usually while solving the mathematics problems, two things are important. One is accuracy and other is speed. For CGL, we have to solve 100 questions in 2 hours. So in that case, both accuracy and speed are important. In fact, speed is little bit more important because we have to solve as many questions as possible. But for CSAT, accuracy is most important because we just need to qualify. We need to do it correct rather than solving it faster because we'll have ample amount of time. So that's why I want you to know that whatever the problems I will tell, I will teach it through the concept only. I don't use any shortcuts or anything because accuracy is important. So you need to know the concept while solving to solve the problem. Okay. So now read the question. So an 8-digit number 4527446b leaves remainder 0. Means this number is divisible by 8. Sorry, 8-digit number leaves remainder 0 when it is divided by 3. Means this number is divisible by 3. So how many values of b are possible? So what is the rule for divisibility by 3? Sum of the digits must be a multiple of 3, right? Sum of digits is multiple of 3. So just add the digits here. So 4 plus 2 6, 6 plus 5 11, 11 plus 2 13, 13 plus 7 20, 20 plus 4 24, plus 6 30, 30 plus b. So this must be the multiple of 3. So now you try the values. So b is a digit, like it should be something from 0 to 9, right? So when b is 0, the sum is 30, which is a multiple of 3. So this is okay. Next, what is the value of b at which this sum will be multiple of 3? Obviously 3. So when b is 3, this is 33, which is again multiple of 3. So when b is 6, it is 36, which is again a multiple of 3. So when b is 9, it is 39, which is again a multiple of 3. So how many values are possible? 0, 3, 6, 9. 4 values. So 4 is your right answer. Next question. So when number 136 is added to 5b7, the sum obtained is 783. So where a and b are integers, it is given that 7a3 is exactly divisible by 3. So the only possible value of b is, so they are telling 136 is added to 5b7 and the sum is 7a3. So if you see here, 7 plus 6 is 13. So b plus 4 is here 7 is there, 5 plus 1 is 6, so we have, it should be 1, so this b plus 4 will result in 1a. That's why we are putting 1 here, so overall the sum will be becoming 7. So let's see, and they are again, and what else they are giving, 7a3 is exactly divisible by 3, means 10 plus a is divisible by 3. So 10 plus a is must be divisible by 3. So what values it is possible? So if a is 2, then the sum is 12, which is divisible by 3. So when a is 5, it is 15, which is again divisible by 3. So when a is 8, it is 18, again divisible by 3. So for a, only 3 values are possible for us. So it can be either 12 or 15 or 18. So what if a is 12? Then the value of b is 8. So what if the a is 15? Sorry, this a is 5 means 15. So the value of b must be 11. But here the b is a digit. B is a integer. So this is not possible. And what is the next value of a? A is 8. 8, right? 8 means 18. So when a is 18, b is 15, which is again not possible, as b is a single digit, right, from here. So the only value of b which is possible is 8. So I'll explain you again. So see, they are telling when 136 is added to 5b7, the resultant sum is so when 136 is added to 5b7, the resultant sum is 7a3. So how can you do this? 7 plus 6 is 13. So b plus 3 plus 1 4 is a, and here they are telling 7, right? So there 1 should be there. So therefore b plus a should be 1 and a. A and b both are digits. And again they are telling 7 plus 3 is divisible, exactly divisible by 3. That means 10 plus a is a multiple of 3. Only then it will be divisible by 3, right? Sum of digits must be a multiple of 3. So what are the values for which it is possible? So a can be 2. So if a is 2, then 12 is multiple of 3. Then it is possible. A is 5 and a is 8. Then it is possible that 7a3 is divisible by 3. So when a is 2, the value of b is 8. When a is 5, the value of b must be 11, which is not possible because b is a digit. When the value of b a is 18, it is 15, again not possible. So the only value which is possible is 8. So next question. So the number of times the digit 5 will appear while writing integers from 1 to 1000 is. So how will we deal with this question? So first we will take 1 to 100. In this 5, 15, like this 95. So in units place 5 will come for 10 times, right? And then there will be a 50, 51, like this till 59. So here also 1, 2, 3 to 10 times. 50, 51, 52, till 59 it is 10, right? 10. So 1 to 100 it is coming 10 times. So again same with 100 to 101 to 200 also it will come 20 times. 10 plus 10, 20 times, 20 times. Like that till 1000 times it will come 20 into 1, 2, like that 10 will be there, 200, right? But if you observe from 500 to 599, the 5 will come in hundreds place for 100 times. Simple. 500 to 599 there will be 100 numbers, right? So 5 will come at hundreds place for 100 times, which is an extra 5. So you have to add 100 again. So total how many times 5 digit is appearing? 300 times. So next question. What is the remainder when 51 into 27, 35 into 75 is divided by 100? So for this what we can do? See, we can write like this. There will be two methods for this. One is directly guessing. We went 27 into 35 into 62 into 75 by 100. See, for 100 there will be, so what is the factorization of 100? 2 square into 5 square, right? 4 into 25. So if there is 1 4 and 25 in a multiplication, then the remainder will be 0 when divided by 100. But here if you observe, 25 into 3 is there. This is 31 into 2 and there is no 2 anywhere. So only 1 2 is there. So obviously what will be the remainder? 25 into 2, which is 50. If one more 2 is there, then 25 into 4, which become 100. So the remainder will become 0. This is one method. So I'll tell another method. See, now you take out 25 here and here from this multiplication. So 25 into 51 into and also take out 1 2. 25 into 2, you take out 25 into 2, so then the multiplication becomes 51 into 27 into 35 into 31 into 3 by, here also you take out 25 into 2. So what will be this thing? 2. So this is like, see, 1 51 27 35 31 and 3. So everything is a odd number. So when odd into odd, the resultant will be an odd number. So this whole thing will be a odd number. So when an odd number is divided by 2, the remainder will be 1. If you see, whatever may be at the unit digit 1 3 5 7 9, when it is divided, when a number is divided by 2, whatever the digit, whatever the odd digit may be at the units place, like 1 3 5 7 9, the remainder will be 1 only. So for this, the remainder is 1, but you have to multiply here with 50. So the remainder will be 50 into 1, which is 50. So if a 5-digit number, if a 5-digit number 538xy is divided by 3711, then the value of x square plus y square. So they are basically telling this 538xy is divisible by 3711, means remainder will be 0 when this is divided by either 3 or 7 or 11. So if you observe here, 3 7 11 are all prime numbers. So if a number is divisible by 3 7 and 11, then it should be definitely divisible by 3 into 7 into 11, because everything is a prime number. So all these three are prime numbers here. So what is 7 into 3 into 11? It is 77 into 3, which is 21 231. So they are basically telling this number is divisible by 231. So they are asking for us to find out this xy. So let us take the number 5 3 9 and 00 and let's divide it by 231. We have to find out the x and y. So for this, to find out x and y, I am taking 53900, see, maximum number, and I am dividing it by 231. So what can we do? Into 2 is 4 6 2. So 7 7 0. So again now it will go with 3, right? So 6 9 3 and the thing remaining is 7 7 0. Now again it will go with 3 6 9 3. So the remainder is 77. So now if we subtract 530 if we subtract 77 from this 53970, then the resultant number will be definitely divisible by 231, because see, this is the remainder. If we subtract remainder from this, then whatever the number resultant number, it should be divisible by 231. So our required number is 53823. So what is x? X is 2, y is 3. So x square is 4 plus y square is 9. So required number is 13. So next, when 732 is divided by a positive integer x, the remainder is 12. Means they are telling when 732 is divided by x, the remainder is 12. That means what they are telling is 732 minus 12. Same concept which I am applying here. See, when 539 00 is this remainder, if we are taken out, then the resultant number is multiple of this number. The same concept we will apply here. When 732 the remainder 12 is taken out, means 720. So this 720 is a multiple of this x, means this x is a factor of 720. So how many such possible values of x is possible? They are asking this. So if you see, so there are many factors for 720, but if the factor is less than 12 or less than or equal to 12, then the remainder will not be 12, because see, if for example let's say x is 6, then this 6 is divisible, like when this 6 divides this 732, the remainder will be 0, because this 12 is also divisible by 6. So this 6 is also a factor of 720. So whatever we are looking for that egg, whatever the factor of 720 we are looking, this x should be more than 12. This is the basic logic of this question. So we have to factorize 720 now. We have to find out how many 720 has how many factors. So how we will write 720? So we can write 8 into 90, right? Or we can write 16 into 45, means 2 power 4 into 9 into 5. 9 means 3 square into 5. So as I told, the formula for number of factors will be a plus 1 into b plus 1 into c plus 1. So a is 4. So number of factors will be 5 into 3 plus 2 plus 1 3 into c is 1. So 1 plus 1 2. So total 30 factors will be there. So in that we have to remove the factors which are less than or equal to 12. So what are the factors of 720 which are less than or equal to 12? So 1 is a factor, obviously. 2 is also a factor because 2 into 360. 3 is also a factor, 3 into 240. 4 is also a factor, 4 into 180. 5 is also a factor of 720 because 0 is there, no? Last digit 0, so it must be divisible by 5. So 6 is also a factor, 6 into 120. 7 is not a factor. If you see 7, it is not divisible by 7. So again 8 is also a factor, 8 into 90. 9 is also a factor, 9 into 80. Again 10 is also a factor, 10 into 72. 12 is also a factor. So less than or equal to 12, how many factors are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have to remove this 10 factors from 30. So 30 minus 10, 20. So 20 values of x. So 20 values are possible for x. So I'll explain again. I know it is a little complex thing. So let's see. See, when 732 is divided by x, they are telling remainder is 12. So this means 732 minus 12, which is 720. For this 720, x is a factor. Means when x divides this 720, obviously the remainder will be 0. So x is a factor of 720. Okay. And so there are many factors of 720 like 1, 2, 3 which are less than or equal to 12. Which are less than or equal to 12. When this factor is divided, then the then when the x is 3 or 4, the remainder will not be 12. So for this to happen, x must be more than 12. X should not be less than or equal to 12. So we have to find out number of factors of 720 then. So what is so n, which is 720, can be written as I told you 16 into 45. So 16 means 2 power 4 into 45 means 9 is 3 square into 5. So what is the number of factors? 5 into, so I mean 4 plus 1 into 2 plus 1 is 3 into 1 plus 1 is 2. So total number of factors is 30. So in this, the possible values of x should not be less than or equal to 12. So how many factors are there less than or equal to 12 for 720? So we have to list them out. 1 is a factor, 2 into 360 is a factor of 720, 3 also is factor, 4 is also a factor, 5 is also a factor, 6 is also a factor, 7 is not factor because 7 doesn't divide 720. So 8 is also a factor, 9 is also a factor, and 10 is also a factor. 11 is not a factor, obviously. If you see, 11 doesn't divide this 720. Again 12 is a factor. So how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have to remove this 10 from this 30 to get our answer. So 20 values are possible for x. Next question. How many 5-digit prime numbers can be obtained by using all digits 1, 2, 3, 4, 5 without repetition of digits? So for this, simple logic is, we know that, see, when they are asking for a combination, like they are giving us 5 digits and they are telling to form any 5-digit number which is prime. Prime number means it should have only 1 and itself as a factor, right? So for this, we will check divisibility by 3 at the outset. So divisibility by 3, what it states? Sum of digits must be a multiple of 3, then it is divisible by 3. So what is the sum of digits here? Sum of digits is 1 plus 2, 3, 3 plus 3, 4, 6, 6 plus 4, 10, 15. So 15 is a multiple of 3, right? So whatever number you form with this combination, that number would be divisible by 3, because the sum, whatever the number you form using these 5 digits, the sum of digits will remain same, 15. So which is a multiple of 3. So whatever number you form using these 5 digits, it must be like it would be divisible by 3. Hence it would not be a prime number. So how many prime numbers are possible? No prime number is possible, 0. Next, how many zeros are there at the end of following product? So as I told, 2 into 5 is 10. So 1 2 and 1 5 presence in a product will make 1 0. So we have to find out how many 2's are there, how many 5's are there. Whatever is the least among these, such number of zeros will be there. So first let's find out number of 5's or number of 2's per se. So here in this 2 into 5, 1 is there. Here it is 4 into 5. So 4 means 2 square, 2 are there. Here it is 2 into 15, 1. Again here 8 into 5 means 8 means 2 cube, 3. Here 2 into 25, 1. Here 60 means 4 into 15, 2. So how many 2's are there? 2's are there, 1, 3, 4, 7, 8, 10. So how many 5's are there? So 1, 5 2's are 1, 5 3's are 1, 5 4's are. Here 5 square means 2. 1, again 1, 5 7's are, 5 8's are 1, 5 9's are 1. Again here 25 into 2, right? 2, 1, 1. So total how many? Here we have 1, 4, 6, 10, 14. So number of 5 is 14. So which is minimum 10. So number of zeros will be 10. Because 2's are less in number. Like 10 2's are there, but 14 5's are there. But number of zeros will be 2 only, 10 only. So next. So they are giving this number 3 7 9 8 1 2 5 P 3 6 9, and they are telling this is divisible by 7. So we have to find out the digit P. So I told you, the divisibility for 7, we have to make 3-digit groups from the right. So this is one group, this is one group, this is one group, and this is other group. So we have to add alternate groups and subtract the sums. So what is 369 plus 981? 10, 15. So 1350 minus 37 minus 25p. So first we will find out this. So 50 minus 37 is 13. 1313 minus 25p. So now we have what maximum we can do is hit and trial and error only. So first we will put 1. So 1313 minus 251 is 2601. So 1602 7. So 7 15s are 105. So 12. So 7 1s are 7. So the remainder is 5. So this is not divisible. So 1 is not the answer. Next we will try 6. So 1313 minus 256. So what is the answer? 7. 13 minus 6 7. 10 minus 5 5. 2 minus 2 0. 1057. So 1057 by 7. 15 105 0 7 1 7. So 0. So remainder is 0. So then 6 is our number. 6, because by substituting 6 we are getting when we substitute 6 here, the divisibility rule of 7 works. So 6 is our answer. So the number of digit 5 will appear where, okay, I think this question has repeated. This answer is 300. So I think second or third question. So what is the total number of digits printed if a book containing 150 pages is numbered from 1 to 150? So a book has they are telling a book has 150 pages, and how many digits are being used? How many digits are used for printing 1 to 150? So this is also again we have to go sequentially. So 1 to 9. So they are using only one digit, right? So how many digits they are using? 9. From 10 to 99 means here till here 9 are used. So 99 minus 9, so 90 numbers are there. But here for every number they are using 2 digits, like this is a 2 digit numbers. So 90 2 digit numbers, right? So 90 into 2, 180. Next, from 100 to 150, how many numbers are there? 100 to 150, 51. But these are all 3 digit numbers, so they are using 3. So 153. So how many overall, how many digits? 9 plus 3 12, 8 plus 6 14, 342. I hope it is clear. I'm just counting the digits. So 1 to 9 only single digit, so 9. 10 to 99 there are 90 numbers, but every number is a 2 digit number, so 180 digits. 100 to 150 everything is a 3 digit number, so 3 digits. There are certain 2 digit numbers. The difference between the number and the one obtained after reversing is 27. How many such maximum 2 digit numbers are there? So they are basically telling there is a 2 digit number AB. So this can be represented as 10A plus B, because this is units place, this is tens place. For example, let's say 23. So 10 into 2 plus 3 means 20 plus 3 is 23. So we can represent it like this. So they are telling the difference between the number and the one obtained on reversing it. So they are reversing it. BA means 10B plus A. So the difference between these two means 10A minus A, 9A minus B minus 10B means 9B. So the difference is 9 into A minus B. This is always 27. They are telling this is always 27. So how many such maximum 2 digit numbers are there? So they are telling this difference on reversing the number is 27, means A minus B is 27 by 9, which is 3. So they are telling how many such numbers are possible with difference 3, right? So let's say A is 9, then B becomes, difference is 3, right? So 6. So on reversing it, 69. So the difference is 27. So this works. The same way 8, let's put 8, A as 8, then B becomes 85. So 58, again the difference is 27, it works. So like this 74, again 63 is possible because 36 which leads to 27, 52 is possible, 41 and 30 is also possible because on reversing it becomes 3 is 27. So how many such combinations are possible? 1, 2, 3, 4, 5, 6, 7. But here 7 is not there, so none of the above. Actual answer is 7. Next, integers are listed from 70 to 100. In how many integers the sum of digits is 7? So the basically the 700 to 1000 integers are there. In how many such integers the sum of the digits is 10? So this 1000 is excluded because the sum of digits here is 1 only. So they are telling let's see from when the 100 digit is 9. I mean 900 to 1000, how many digits are possible? So there are 2 digits only. So if the sum is 10, means only combination possible for us is 0 and 1, right? Because 9 plus 0 plus 1 is 10. So how many are possible? One is 901, one is 910. Next, when we take 8, so 8 to for 8 how many are possible? Either so 8 plus 2 is 10, right? So either 2 or 0, either 1 and 1 is also possible because 8 plus 1 plus 1 is also 10. So how many such numbers are possible here? 820, 802 and 811, right? When we take 7 as our number, like they are telling only above 7, right? So when we take 7, so 7 plus 3 10, so 2 comma 1 is possible and 0 comma 3 is also possible because in the both cases the sum is 10. So how many numbers? 721 and 712, 730 and 703. And we can't take 6 because they are telling only 700 to 1000. So now count how many numbers are there. One is 901, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 is our answer. So 9 such numbers are possible. So the difference between a 2-digit number and the number obtained by interchanging the positions of digits is 54. So the same concept, the which we have dealt here. So basically they are telling if a number is AB, let's say the number is AB, So it is reversed, BA, the difference. So you refer to this question, what is the difference here? The difference is 9A minus B, right? 9A minus 9B. So the same way here, the difference 9 into A minus B, they are giving it as 54. The difference is 54. So the A minus B is 6. So now they are telling to consider the following statement. So first let us see how many combinations are possible for this. So if A is 9, then B is 3, right? Because difference between the digits is 6. If A is 8, then 2. Then B is 2, 82. If A is 7, 71. A is 6 means 60. And below it, it is not possible because the difference is 6. So they are telling the sum of two digits of the numbers can be determined only if the product of two digits is known. So what is the product of two digits here? 27. Here it is 16. Here it is 7. Here it is 0. So everywhere the product of two digits is unique. 27, 16, 7 and 0. So here if we know this, then we know the sum, right? If the product of two digits is 27, then the sum is 12. If the product is 16, then the sum is 10. If the product is 7, then the sum is 8. If product is 0, then the sum is 6. So whatever they are telling, the sum of two digits of the number can be determined only if the product of two digits is known is true. Because if the product is known, if product is 27, then we are telling the sum is 12. If the product is 16, then we are telling the combination is 8 and 2 and the sum is 10. So first statement is correct. Second, the difference between the two digits of number can be determined. Obviously the difference between the two numbers is always 6, which is determined. So both of them are correct. So I will tell you again. See, they are telling basically the difference between a two-digit number and the number obtained by interchanging the position is 54. See, let's say this AB is two-digit number and the difference between the number and the number obtained by interchanging the positions will be 9A minus B, which we have seen in the last problem. So this they are giving 54. So basically A minus B is 6 it is getting. So the second statement, the difference between two digits of the number can be determined is true because it is always 6. Now how many combinations are such possible? One is 93, second is 82, third is 71 and last is 60. So first statement is the sum of the two digits of number can be determined only if the product of two digits is known. So what is the product of two digits here? 27. So when the product is 27, then the sum will be 12. If the product is 16, then the sum will be 10. If the product is 7, then the sum is 8. If the product is 0, then the sum is 6. So if they give you the product of two digits, you can find out the sum of two digits. So this statement is also true. So both of them are true. So how many triplets x, y, z satisfy the equation? How many triplets x, y, z satisfy the equation x plus y plus z is equal to 6? Where x, y, z are natural numbers. So with this, what can we do? So x, comma y, comma z, nothing can be equal to 0 because only x, y, z are natural numbers only. So it should be either 1 or more, right? So they are telling x plus y plus z is 6. So how many combinations are possible? So we can't take 0, right? So 1, if we take 2 ones, then it is 4. So here the formula is, so we have to find out the permutations, right? So 3 numbers are there, 3 factorial by, because one digit is repeating, 2 factorial, it is 3. If you don't want to learn like this, you can just write down the combinations here. So 1 1 4 is 1, 1 4 1 is such 1, 4 1 1 is 1. So next is you can use 2 is also possible, right? Sum is 6. So 2 only one combination is possible. Next is 1 2 3. So the number of ways this, so 1 plus 2 plus 3 is 6. So number of ways this can be arranged is 3 factorial. What is the formula of factorial? 3 into 2 into 1. So 6. So for 1 2 3 combination, 6 things are possible. Here only 1. Here 3. So total how many combinations are possible? 3 plus 1, 4 plus 6, 10. 10 are possible. Next, a two-digit number, again the reverse based question. See, the two-digit number is reverse. The larger of two numbers is divided by the smaller one. What is the largest possible remainder? So for this, you just take the largest possible two-digit number is 99. So if we reverse this, it is same. So let's take 90, from 98 you can take. If we take 98, the reversal is 89. So they are telling when the larger of the two is divided by smaller. So what is the remainder here? It is 9. They are asking the largest possible remainder. So then take 97. So it is 79. Here the remainder will be difference of these two, like this. Here the difference is 9, the remainder is 9. So here is also, because anyhow it will divide only one time, like 79 ones are 79. So the remainder will be 18, right? Next take 96. It is 69. So the remainder will be here 27. Take 95. It is 59. The remainder is 36. Next 94. The reversal is 49, and the remainder is 94. If 94 is divided by 49, remainder is 49 1 is 49, 45. So the remainder is 45. So when we take 93, 39. So now it changes, because 93, 39, it takes two times. 78, the remainder becomes 15. Again 92 also, the remainder is 29 into 3 is 87, right? So remainder is 5. So the largest possible remainder is 45. After this, the remainder is reducing. So this is the answer. So here, how many natural numbers are there such that difference of their squares is 63? So they are telling how many pair. Pair means one pair x and y. It is the pair of both are natural numbers. And difference of squares is 63. So let's take x square minus y square. They are telling it is 63, right? So this x square plus y square we can write as x plus y into x minus y. Everyone knows this. And here we have to factorize. So how many factors how many ways we can factorize? 1 into 63, and this doesn't divide with 2, right? So 3 into 21, then 7 into 9, then so only these are the possible combinations. So if so how many such pairs are possible? So if x plus y is equal to 63 and x minus y is equal to 1, so what is x? X is 64 by 2, 32, and y is 31. So one pair possible is 32, 31. Second, if x plus y is 21 and x minus y is 3, what is the possibility? X is so 2x is equal to 24, x is 12 and y is 9. So one such pair is 12 comma 9. And next is x plus y is 9 and x minus y is 7. So what is the possibility? 16 comma 8 comma 1. So only these three pairs are possible. So answer is 3. So this question will be dealt under HCF and LCM concept. Next is, see, while writing the numbers from 700 to 1000, how many numbers occur in which the digit at hundreds place is greater than the digit at tens place, and which is greater than digits at unit place? So they are telling basically the 3-digit number in which the number at this place should be greater than this, and the number digit at this place should be greater than this, and the number should be from 700 to 1000, means 3-digit number. So let's count. So if for example say the number starts with 7, so obviously the next possibility is 6 here. So here it can be 0 1 2 3 4 5 6. So sorry, 0 1 2 3 4 5, because it should be greater than this. So total 6 possibilities are there. If 5 comes, then 0 1 2 3 4, so 5 possibilities are there. So like that till 1. So if there is 1, then only possibility is 0, so 1. So when the number starts with 8, so if 7 comes here, so here the possibilities are from 0 to 6. 0 1 2 3 4 5 6. So total number of possibilities in this scenario is 7. If it is 6 here, then the total number of possibilities are 6. So like that, when it is 1, it is 810. So the only possibility is 0, so the number of possibilities is 1. So similarly, when the first digit is 9 and second digit is 8, there will be 8 possibilities here, 0 to 7, right? Similarly, when it is 7, then 7 possibilities. Like that, it will be when it is 1 possibility, that is 9 10, 9 10. So now we have to count all these things, all this. So 1 to 6, 1 to, so sum of 1 to 6 is 6 into 7 by 2. I mean sum of n natural numbers. So 1 2 3 4 5 6, the sum is 21. So 21 plus here 21 plus 7, 28 plus here 20, so 1 to 7 is 28 plus 8, 36. So what is the sum? You can see here 49 plus 36 is 85. So total 85 possibilities are there. So next question is, what is the remainder when 5 power 70 plus 7 power 70 is divided by 74? So you need to bring it in a power n plus b power n. It is already in that form, but try to bring it in a power n plus b power n when n is odd. So you can do it like this. So here 5 square whole power 35 plus 7 square whole power 35. So this is clearly 725 power 35 plus 49 power 35. So when we know that when a power n plus b power n, when n is odd, so this is divisible by a plus b, which is a is 25, b is 49, which is 74. So they are asking the same. So when this number, when this is divisible by 74, when any number is divisible by any number, then the remainder will be 0. So obviously when 12 is divisible by 6, the remainder will be 0, right? So this is factor of this, so the remainder will be 0. As this number is divisible by 74, the remainder will be 0. So next is, what is the remainder when 441 into 662 into 293 to 515 is divisible by 73? So for this we have discussed the second method of finding remainder, right? So we have to find the 73 multiple which is near to 441. So try 73 into 6. So it is 438, right? So you can write 438 plus 3 into, similarly here 73 which is 662. So try 73 into 9. So 9 3 is 27. So 9 7 is 63, 657. So 657 is divisible by 73, obviously, plus 5. So similarly 73 into 4 is 292. So 292 plus 1, right? Then 73 into 5, like around nearby, take 7. So 7 3 are 21, 511, right? So 511 plus 4. So all these numbers are divisible by 73. So whatever the multiplication, only when these, see in this multiplication, 438 plus 3 into 657 plus 3 plus 5 into 292 plus 1 into 511 plus 4, the only number which is not divisible by 73 is the multiplication of 5 into 3 into 1 into 4. So 5 into 3 15, 15 into 1 15 plus 15 into 4 60. So whatever the number comes here in the multiplication, it will be in form of 73 into k, some k, because every 438 is divisible. See, for 657 is divisible, 511 is divisible, and 292 is divisible. So this whole product will be in the form of 73 into k plus the product of this unit digits, like the product of this 4 1 5 1 3. So it will be like this. So when this number is divided by 73, then remainder will be obviously 60. I hope it is clear. I'm just telling to rewrite these things as a multiple of 73 plus some number. So this 441 becomes 433 plus 8, 662 becomes this 657 plus 5, 293 becomes 292 plus 1, 515 becomes 511 plus 4. So all these are multiples of 73. So finally, when this whole multiplication we perform, this will be in form of 73 into k plus the multiplication of these 4. So 4 1 are 4, 4 5 are 20, 20 into 3 60. So when this number is divisible by 73, the remainder will be 60. So next problem is also same. What is the remainder when this is divisible by 59? So we have to try to make this thing into something, some multiple of 59 plus or minus something. So try. So 63 is 180, right? So try 59 into 3 is 177. So this can be written as 177 minus 2 into next 59 into, we can write 5. So 5 9 is 45, 295. So 295 minus 4 into next 59 into 8, let's say 7 9 is 63, 7 5 is 35, 413, right? So 413 minus 3 into 59 into 9, 9 9 is 81, 9 5 is 45, so 531. So 531 plus 1. So again, see here also this 177, 295, 413 and 531 all are multiples of 59, right? So it will be in the form of 59k plus product of all these. So minus 2 into minus 4 is minus 8, sorry 8. 8 into minus 3 is again minus 24. Minus 24 into plus 1 is minus 24 it will be. So for this we have to write like this, 59 into k minus 1. So k minus 1, so we are subtracting 51 and we will be adding 59 here again. So 59 into k minus 1, so we are subtracting a 59 and adding a 59 on the outside. So this will become 59 into k minus 1 plus 59 minus 24 is 35. So this is same as this. So when this is divided by 59, what is the remainder? So when this is divided by 59, the remainder will be 35. So 35 is our answer. I hope you understand. So next question is, if a 8-digit number 888x5354 is divisible by 72, find 7x plus 25 for the maximum value of y. So y is maximum. So obviously I told, so if it is divisible by 72 means, what is 72? 72 is 8 into 9, right? 8 9 is 72. So it should be divisible by both 8 and 9. So what is the divisibility rule for 8? So the last 3 digits 3 by 4 must be divisible by 8. So see the possibility. So if y is 0, 304 by 8. So 8 3 are 24, 64. So 8 8 ja, so 304. So y0 is possible, 304. And the next plus 40 means 344. Next plus 40, because 8 5s are, it is 8 multiple, right? Only plus 40 only it will divide by 8, because I'm comparing the things here. So 384. So the possibilities of y are, so y possibilities are 0, 4 and 8. Okay, so they are asking for the maximum value of y, right? So y will be 8. So and it should be also divisible by 9, right? So the sum of digits goes. So for divisibility, what is the divisibility rule of 9? The sum of digits must be a multiple of 9. So do the sum of digits. 8 plus 8 16, 16 plus 8 24, 24 plus 5 29, 32, 32 plus y, the maximum value of y is 8, right? So 32 plus 8 40, 40 plus 4 44 plus x. So this should be divisible by 9. So what is the possible values? If x is 1, then it is 45. So it is divisible by 9. So next is x is 10, it is 54, it is divisible by 9. But x is a single digit and 10 is not possible. So only value possible for x is 1. So then 7x plus 2y. So here x is 1 means 7 plus y is 8, 16. So 7 plus 16, 23. So I will explain this again. See, they are asking this, they are telling this 8-digit number is divisible by 72. Find out 7x plus 2y for the maximum value of y. So if a number is divisible by 72 means what is 72 is 8 into 9. So then this number should be divisible by both 8 and also 9. So first we are looking at the divisibility rule of 8. So for any number to be divisible by 8, the last 3 digits must be divisible by 8, right? So 3 by 4. I am taking y as 0. So this 304 is divisible by 8, as you can see here. 8 8 is 64, remainder is 0. So then the next value will be plus 40, because 8 5 is 40, right? We have to add 8 multiple only. So 344, next plus 40, 384. They are asking for the maximum value of y. So our y is 8. So y is 8. So next we have to check the divisibility with the divisibility rule of 9. What is the divisibility rule of 9? Sum of all digits must be a multiple of 9, right? So I am doing sum of digits. 8 8 8 24 plus 8 5 plus 3 8 32 plus 4 36, and y we got 8. So 44. 44 plus x, this should be multiple of 9. So for the value of 1, if x is 1, then this is 45, which is multiple of 9. Then the next value possible is 10, which is not possible because x is a digit. So our x is 1, means 7, plus y is 18. Sorry, y is 8 means 16. So the value will be 23. So here next problem is, let xyz be a 3-digit number, whereas x plus y plus z is not a multiple of 3. Then this is not divisible by what? So again I told you, like if there is a number called, suppose 816 is there, we can write it as 8 into 100 plus 1 into 10 plus 6 into 1, means unit digits, tens digit, hundreds digit. So we can write this as 100x plus 10y plus z. Next plus 100y plus 10z plus x. So next this thing 100z plus 10x plus y. So if we add all these three, see how many x's are there? 100x plus 10x, 110x plus x. So 111x plus same 100y, 110y plus y, 111y plus same 110 111z. So it is 111 into x plus y plus z. So as I told you, the 111 is only prime number, like only factors possible are 3 into 37. If you remember, I have told this earlier in the video. So this can be written like this: 3 into 37 into x plus y plus z. So they are asking, this is not divisible by. So see the options. X plus y plus z is there, so it is divisible by x plus y plus z. 37 is there, it is divisible by 37. 3 is also there, it is divisible by 3. So the only thing which it is not divisible by is 9. Next is, if a 9-digit number 8475693AB is divisible by 99, find the values of a and b. So same, what is the rule for 99? Earlier only we have seen that for 72 it should be divisible by both 8 and 9, right? So for 99 the number should be divisible by both 9 and 11, right? So first we will check the divisibility rule by 9. So what is the divisibility rule of 9? The sum of digits must be a multiple of 9, right? So do the sum of digits. So 8 plus 4 12, 12 plus 7 19, 19 plus 5 24, 24 plus 6 30, 30 plus 3 33 plus 42. So 42 plus a plus b. So this should be multiple of 9. So a plus b can be 3. If a plus b is 3, then it is 45, which is multiple of 9. And a plus b can be 12. If it is 12, then it is 54. And then a plus b can be 21, which is not possible because both a and b are digits. They can't be more than 10. So this 21 is not possible. So either it is 3 or 12, right? So next we have to check with 11. So what is the 11? Sum of alternate digits. So write it this like this: 5 6 3 9 a b. So map the alternate digits. Okay, So b plus 9 plus 6 15, 15 plus 7 22 plus 8 30. So 30 plus b, a plus 3, a plus 8, a plus 12. So 4 plus 5 9 12, a 12 plus a. So this is 18 plus b minus a. So so now see the options. It is better to see the options. So we are getting a plus b either 3 or 12, right? So here any option a plus b 3 is not there. Only a plus b 12 is possible. So what are the options? So 9 and 3 is there and 4 and 8 is there. Okay. So now try here. So try options a as 3 and b as 9. Okay. So what will it get? It is 24. So which is not a multiple of 11. Okay. So next try 4 and 8. So it is 4, it is 8. So 18 plus 8 minus 4 is 22, which is a multiple of 11. So by checking the options, we came to conclusion that this works. So this is the answer. I hope you understand. I just find out the possibilities, and after that I verified it from options, which is a, rather than solving this, I verified from the options, which saves my time. So next is, if two numbers x and y are divided by 17, the remainders are 6 and 8 respectively. So they are telling if x is divided by 17, the remainder is 6. So you know the dividend and dividend rule, right? Dividend is equal to quotient into divisor plus remainder. So we'll write like this. Let here the quotient is a. Let's say the quotient is a. Then x is equal to, so x is divided by 17, right? So 17 into quotient 17a plus 6. So they are telling then when y is divided by 17. So if y is divided by 17, remainder is 8. So let's say the quotient here is b. So if y is divided by 17, divisor into quotient b plus 8. So when the product xy is divided by 17, so find out the product xy. So this 17a into 17b plus see here 17a into 8 plus 17b into 6 plus 48. So when this is divided by 17, see the first term is divided by 17, second term is also divided by 17, and third term is also divided by 17, because the as I told earlier, when the product of these two happens, only term which is not divisible by 17 is this thing. So the 48. So when 48 is divided by 17, what is the remainder? 34, which is 14. So the 14 is our remainder. So I will explain again. See, you know the dividend rule, right? Dividend is equal to quotient into divisor plus remainder. So now they are telling when x and y are divided by 17, remainders are 6 and 8. So when x is divided by 17, remainder is 6. I am just taking quotient as a. So then x is 17a plus 6. Same y is 17b plus 8. So when the product is divided by 17 means when the product happens, there will be 4 terms. So out of 4, in 3 terms 17 will be there. 17 into this and this. The only term in this there is no 17. So the remainder will be the same, which remainder will be the same when this is divided by 17. So 48 divided by 17 gives me remainder as 14. So next is, if a number is divided by 312, the remainder is 59. So let's say the number is n and the quotient is a. So when the number is divided by 312, they are telling the remainder is 59. So how can we write? So number is equal to divided by 312 means divisor is 312 into quotient plus 59. Now they are telling the same number is divided by 24. Same number is divided by 24. What is the remainder? We have to see whether this is divided by 24 or not. So if 312 is divided by 24, then this whole is divisible by 24. So I will find out whether 312 is divisible by 24 or not. So 24 1 is 24, 7 2, 24 3 is 72. So 0. So remainder is 0. So this is divisible by 24. So now the remainder will be the same, which when 59 is divided by 24, what is the remainder? 2 is 48. So 11. So when n is divided by 24, the remainder will be 11. The same, because this is divisible by 24. So which one of the following is a factor of 8 power 2n plus 5 power 2n, where n is a odd number? So the same. So we have to make n as a odd number, right? So we know a power n plus b power n is divisible by a plus b when n is a odd number. So now here rewrite this like this: 8 square whole power n plus 5 square whole power n. So it is 64 power n plus 25 power n. So here n is odd number. So obviously this is, when n is odd number, this is divisible by 64 plus 25, which is 89. So 89 is a factor of this thing. So the 6-digit number, next problem is, if a 6-digit number 5x2 y6z is divisible by 7, 11, 13, then the value of x minus y plus 3z. So I told, when the number is divisible by 7, 11 and 13, this number will be in the form of ABC, ABC, as it is divisible by 1001. If you go through the concepts I have told, when the number is divisible by 7, 11 and 13, then the number will be in the form of ABC, ABC. So we see here, we map, so this is this, see, A is 4th, so X is this and this is this. So X is equal to 6, Y is equal to 5 and Z is equal to 2. So X minus Y, 6 minus 5 is 1 plus 3 into Z is 2, 6 is equal to 7. So if a 5-digit number 247xy is divisible by 3, 7 and 11, find the value of 2y minus 8x. So I have told, when a number is divisible by 3 prime numbers, 3, 7 and 11, so this should be divisible by the product of the prime numbers also. So 21 into 11, 231. Means when a number is divisible by 3, 7, 11, which are prime numbers, then it should be also be divisible by 3 into 7 into 11. So take the number as 24800, for example. Let's say it is 231. Let's say let's divide this by 231. So 1 ja 231, 7 1 0 0 0. 231 into what can we take? Take 7. 7 1 ja 7, 7 3 ja 21, 7 2 ja 14, 16. So 83. So when 2480, when we subtract 83 from this, the resultant number is 24717, and this is divisible by 231, because I have told you now, when we subtract remainder from this dividend, it will be divisible by the divisor, because the remainder will be 0 then. So what is our x? X is 1, y is 7. So 2 into 7, 14 minus 8 is 6. If a number is successively divided by 6, 4 and 7, if a number is successively divided by 6, 4 and 7, it leaves remainder 3, 1, 5 respectively. Find the remainder when it is divided by 17. So I told you the concept of successive remainders. So you have to write like this: 6, 4, 7 and here 3, 1 and 5. So take the last quotient as 1. So what will the number here? 7 plus 1 plus remainder 5. So 7 plus 5 is 12. So 4 into 12 plus remainder is 1. So 12 4 is 48 plus 1 is 49 plus remainder is 3. So 49 into 6 is 9 6 is 54. 294 plus 3 is 297. So this can be our number. So when 297 is divided by 17, so we know 17 17 is 289, right? 17 square. So it is 8. So the remainder will be 8. So next is, what is the least 4-digit number when divided by 3, 4, 5 and 6 leaves a remainder 2 in each case? So first we have to see whatever the number n, it will leave a remainder 2 in each case, but it is divisible by both all 3, 4, 5 and 6. So what is the number which is divisible by, least number which is divisible by all these 3? So 3 4s are 12 into, so in this 12 6 will come, 12 5 is 60. So 60 is the number which is the least number, means the LCM of 3 4 5 6 is 60. So whenever see, check from the options, when you remove 2 from the options, it should be divisible by 60, then that will be our correct answer. So here if we remove 2, 1010, here it is 1020, here it is 1120, here it is 1220. So which is divisible by 60? Clearly this is not. This is 60 17, yeah, this is divisible by 60, and this is also not, this is also not. So this is our answer. So I'm just telling, see, they told the least 4-digit number which when divided by 3 4 5 6 leaves remainder n 2 in each case. So the number, whatever the number is, it will leave remainder 2 in each case, and this number n, so in n plus 2, this n is divisible by 3 4 5 6. So I am just finding the number which is divisible by all 3 4 5 6, which is 60. So this n is also divisible by 60, right? Because this n is divisible by all these 4, it should be divisible by 60 also, because all these 4 LCM is 60. So I am checking from the options. Just remove 2 from here, in from every option, and the resultant thing should be divisible by 60. That would be your correct answer. So I got this, and only this option is divisible by 60, so which is our correct answer. Okay, next. The printer numbers the pages of a book starting from 1 and uses 3089 digits in all. How many pages does the book have? So again I am telling, so he will start from 1, right? So 1 to 9, how many digits? He, like 9 digits, right? Next, from 10 to 99, how many numbers are there? See, till 99, here already 9 were used, so 90 will be there. But for every number 2 digits, right? So for every number there will be 2 digits, because these are all 2-digit number. So 90 into 2, 180. Next, 3 digit. So from 100 to 999, how many numbers will be there? So till here 99. So 999 minus 99, 999 minus 99, 900 will be there, and all are 3-digit numbers. So 2700. So how many are done? 9, 8, 2, 8, 8, 9. So now the 4-digit numbers will start from 1000 to, so how many are left? See, so they are telling 3089 digits were used. So till here we have got 2889 were used. So is 200. So at max we can use 200 digits. But for every number it is using 4 digits, right? So how many numbers are possible? So maximum 200 by 4, 50 numbers are possible from here. So 54-digit numbers. So it is starting from 1000. So it should go till 1049, because if we take 1050, then 51 numbers will be there, but only till 1049 50 numbers. Check, because it starts from 1000. So 1000 to 1049 is 50. So our answer is 1049. So I'll again explain this. This is very important. See, they are telling a printer starts naming, like the printer numbers the pages of a book starting from 1 and uses 3089 digits overall, right? So from 1 to 9 he uses 9 digits. Okay, from 10 to 99 there are 90 numbers. 99 minus 99, out of 99 9 are done, so it is 90 into 2-digit number, so 180. Next, from 100 to 999 there will be 999 minus 99, so 900 into 3-digit numbers, so 2700. So till now he is using 2889, right? So overall he has to use 3089, and out of which 2889 he is already used, so remaining is 200. So now from 1000 4-digit number start, so he can use maximum 200 digits, and every digit is 4-digit number, so maximum 50 pages. So from 1000 it will go till 1049, so that he can name the 50 numbers, like 54-digit numbers. So the book has 1049 pages. Okay, so our next topic is HCF and LCM. So what is LCM? So LCM is least common multiple. So for example, if a comma b are two numbers and say its LCM is x, it means both a and b are multiples of x. That means both a and b divides the x. So for example, take here, so 54 and 72. So if you see here, let's say like 54 and let's say 216, see 216. So it is 54 into 4 and 72 into 3. So here the 216 is the least number which is divisible by both 54 and 72. In other words, this 216 has both 54 and 72. For both 54 and 72, 216 is a least common multiple. So how do we find the LCM? See, so we have to factorize 54, like 18 into 3 we can do, and 72 18 into 4. Therefore 3 and 4 has nothing in common other than 1. The only common factor between 3 and 4 is 1, right? So LCM of 54 and 72 is equal to 18 into 3 into 4, which is 216. So here see, so how to find LCM of 27, 45, 63? Here we can, what we can do is 9 into 3, 9 into 5, 9 into 7. So here 3, 5, 7 has only common factor 1 because all these are prime numbers. So the LCM will be 9 into 5 into 3 into 7, 945. 945 is LCM of 27, 45 and 63. So for example, same, see 36, 45 and 72. How do we find LCM? Here what can we write? 9 into 4, 9 into 5, 9 into 8. So if we take 9 into 8, the 4 comes in this because the LCM of 4 and 8 is 8. So here 5 is there, so into 5. So 9 5 is 45, 45 into 8, 360. So 360 will be LCM of 36, 45 and 72. So in this way we find LCM. Okay. So next is HCF. So HCF, what is HCF? It is highest common factor. So if there is A, B and let's say HCF is X, it means this X divides both A and B. So this A and B are both divisible by X and it is the highest such value. So in other words, it means, so X is the highest common factor of both A and B. So how do we find out the highest common factor? See, for example, here it is 36 and 96. There are several multiple ways to find out the HCF. So one such way is long division rule. See, we should divide the biggest number with smallest number. So 36 into 2 is 72. So we will get 24. So again we have to divide this number 36 with this 24. Till we get a remainder as 0, we have to continue this process. So 24 ones are 24. It is 12. So again we have to divide this 24 with 12. So 12 to the 24 and we get 0. So whatever the least, whatever the last number which comes here is our HCF. So for 12 and 36 and 96, the HCF is 12. So other way to find HCF is to factorize. So 36 can be factorized as 4 into 9, which in the sense 2 square into 3 square, right? So 96, what we can do? 16 into 6, I mean 32 into 3. Okay, so 2 power 5 into 3. So from both we have to take the least powers. So here 2 power 2 and 2 power 5 is there. So in HCF we will take 2 power 2 into, here 3 power 2 and 3 power 1 is there. We have to take 3 power 1. So least power we have to take. So 2 square 4, 4 into 3, 12. So this is the other method to find the HCF. So let's try the next one. So HCF of 216, 312 and 144. So there is one more method to find out the HCF. So if there are three such numbers, what we'll do is subtract this from this. So what is the result? 312 minus 216. It is 96. Then subtract this from this. So what will we get? 168, right? Next subtract this from this. So what we will get is 72. So now we have to factorize this. So this is 24 into 4, this is 24 into 3, and this is 24 into 7. So there is nothing common, like there is no factor, like this 4, 3, 7 are all co-primes. So other than 1 there is no common factor. So then this 24 is the HCF of these three. So what I did, first I have taken 2 at a time and subtracted the smaller ones from the bigger one. So here we will get 96 and here it is 312 actually. So here we will get 168 and with these two we will get 72. And when we rewrite this, so 96 is basically 24 into 4, 72 is 24 into 3 and 168 is 24 into 7. And among these there is no common factor. So 24 into 4, 4, 3, 7 all are co-primes. There is other than 1 there is no common factor. So in this case, so 24 will be our HCF. So other than this, what we can do using factorization method. So 216 is basically 6 cube, right? So 2 power 3 into 3 power 3. So 312. So 312 is what we can write, 8 into 39. So here 2 cube into 3 into 13. So 144. 144 again, 18 into 8, right? Or 16 into 9 we can write. So 2 power 4, 16 into 69 is 144. 2 power 4 into 3 square. So here, so we have to take least powers in everything, in every number. So here 2 power 3, 2 power 3 and 2 power 4. So we will take 2 power 3 into here 3 power 3, here only 3, here 3 square. So we will take 3 power 1. And 13, there is no 13 here and here. So it means 1. So what is the HCF? Means basically 13 power 0, which is 1. So what is HCF? 8 into 3 is 24. So any method we can follow to find out the HCF. So for any two numbers A and B, if its LCM is say X and HCF is Y, then A into B is equal to X into Y. This, remember, this is the formula. So for any two numbers A and B, its LCM and HCF is equal to the product of two numbers. So what about fractions? So LCM and HCF of fractions. So for example, consider A by B and C by D are two fractions. So LCM of A by B comma C by D is, so LCM of A comma C means the LCM of numerators A comma C by HCF of denominators B comma D. Okay, at the same time HCF of A by B comma C by D is equal to HCF of numerators A comma C by LCM of denominators B comma D. So remember this formula, this is also very important. So LCM of two fractions is LCM of numerators by HCF of denominators. HCF of two factors is HCF of numerators by LCM of denominators. Okay. So now let's look at problems. So in a school, every student is assigned a unique identification number. A student is a football player if and only if his number is divisible by 4. So a football player is assigned with the number which is divisible by 4. So it can be 4, 8, 12 like this, dash, dash, dash. Whereas a student is a cricketer if and only if his identification number is divisible by 6. So a student is a cricketer only if his identification number is divisible by 6. So it will be like this. So if every number from 1 to 100 is assigned, so all students are assigned 1 to 100. How many of them play both play cricket as well as football? So they are telling they play both cricket and football. Means whatever number they were assigned, that number should be divisible by both 4 and 6. Means that number should be divisible by LCM of 4 and 6. So what is LCM of 4 and 6? 12 clearly. So whatever the numbers are assigned with multiples of 12, they that student plays both cricket and football. Okay. So how many will be there such from 1 to 100? So 12, 24. So dash 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 till 100 means 96. So this is 12 into 1. So this is 12 into 8. So how many such players will be there? 8. 1 to 8. So what is the greatest length x such that 3.5 meter and 8 3/5 meters are integral multiples of x? So they are asking what is the greatest length x such that this is 7 by 2, right? 3 to the 6 plus 1 7. Here 8 4 to 32 plus 3 35 by 4. So they are asking what is the greatest length x such that these two are integral multiples of x. Means basically they are asking HCF of these two numbers. So they are telling x is HCF of these two numbers. Greatest number x which is such that these two are integral multiples of this. Means indirectly they are telling x is HCF of both of these. So how to find HCF? So HCF of two fractions is HCF of numerators by LCM of denominators. So what is HCF of 7 and 35? Obviously 7, because this is 7 into 1, 7 into 5. So 7 by LCM of 2 and 4 is 4. So 7 by 4 is 1, 3 by 4. So this is. So here they are telling Joseph visits the club every 5th day. Harsh visits the club every 24th day. So Sumit visits the club every 9th day. So they all met at the club on a Sunday. So at a Sunday they are 3 met. Okay. So on which day they will all 3 of them meet again. Okay. So whatever, so they are asking on which day they will meet, 3 of them will meet again after meeting on Sunday. So obviously we have to find out like the next time they will meet, the number of days will be the LCM of these 3. So what is the LCM of 5, 24 and 9? So this is 8 into 3, this is 3 into 3, this is 5. So 8 into 9 into 5. So 360. So from here on 360th day they will meet again. So so after 357, like 357 is divisible by 7, right? So if it is Sunday, then after 357 means the 357th day will be Sunday again, right? Because it is divisible by 7. So the week gets repeat from here. So the 358th day will be Monday. So the 359th day will be Tuesday, and they meet on 360th day, which is Wednesday. So I'll explain this thing again. So basically they are telling Joseph visits the club every 5th day. Means after every 5th day he will visit. So Harsh visits on every 24th day. So Sumit visits on every 9th day. So they are telling they met on Sunday, and on which day they will meet again. So 3 of them will meet again after again on the day of the LCM of these 3. So the LCM of these 3 is 360. So after this they meet again on 360th day. So here 357 is multiple of 7. So from here the 357th day will be Sunday again, because in a week 7 days will be there. After 7 days the day gets repeated, right? So 357th day will be Sunday. So 358th day Monday, 359th Tuesday, 360th Wednesday. So two numbers are in the ratio 7:11. So let us say two numbers are 7x and 11x. So he is telling their HCF is 28. So here we can see this 7 and 11 are co-primes, means the only common factor is 1. So this HCF is X obviously. So X is 28. So now they are asking the difference between the two numbers. So what is the difference between two numbers? 11x minus 4x, it is, sorry, 7x, it is 4x. So 4 into 28. So 112. 112 will be the difference. So the next question is the least number when divided by 80, 48, 64, 90 and 120 will leave the remainders 38, 54, 80 and 110 respectively is. So they are telling there is a number n which when divided by 48 it leaves remainder 38. So when it is divided by 64 it is leaving remainder 54. When it is divided by 90 it leaves remainder 80, and similarly when it is divided by 120 it is leaving remainder 110. So here if you observe, the difference between the divisor and remainder is 10 here. Here also it is 10. Here also it is 10. Here also it is 10. So when so whatever this number is, this must be LCM of all these minus 10. Only in such case the difference between the remainder, that the difference between the divisor and remainder will be the same in each case. Only when the number is LCM of all these minus 10, only in such case the difference between divisor and remainder will be same in each case. So now find out LCM of 48, 64, 90 and 120. So this is basically 16 into 3, right? So 2 power 4 into 3. This is 2 power 6. 64 is 2 power 6. This is 6 into 2 into 45. 3 square into 5. I mean, I am just factorizing. So this is 8 into 15. So 2 power 3 into 3 into 5. So now LCM is, so we have to take highest power of 6. So 2 power 6 into 3 square into 5. So this is 64 into 5 into 9. So 64 into 5 is 5 for the 20. So 320 into 9, which is 2880. So so the n is LCM minus 10, right? So LCM is 2880 minus 10, it is 2870 is our answer. So basically the question tells that whatever the number n is, so when it is equal to LCM minus 10, only in such case the difference between the divisor and remainder will be same for each case. So we have find out the LCM, and the answer is LCM minus 10, so which is 2870. So next question is the greatest number that when it divides 140, 176, 264 leaves remainder 4, 6 and 9 is. So when the number x divides 140, it is leaving remainder 4. When it divides 176, it is leaving remainder 6. When it divides 264, it is leaving remainder 9. So actually this kind of question we can verify from the options also. See, for example, take 264. So if it is divided by 51, 264, what is it? 5 is 255. So remainder is 9. So here 51 when divided 161, 3 is 153. The remainder is 23. So it is not 51. So same is the case with 34. So 34 when it divides 264, 234 7s are 7 4s are 28, 7 3s are 21, 238. So the remainder is 26. So again 34 is not the required number. Also 19, we can try 19. So when 19 divides 140, the remainder is 19 7s are 133, the remainder is 7. So even 19 is not the correct answer. So the only option left is X. Now I will tell the process how to do it. So we can do it from the options also, but how we can do? So when 140 is divided by x, the remainder is 4. Means 140 minus 4, 136 is a multiple of x, obviously. And also 176, when x 176 is divided by x, the remainder is 6. Then 176 minus 6, 170 is a multiple of x. Again here 264 when divided by x, remainder is 9. So 264 minus 5, 255 is divisible by x. So here you can see 17 into 8, 17 into 10, 17 into 15. So if we go for 34, 34 into 2, 34 into 5, but here it is not possible, 34 into, because this 15 is not divisible by 2. So only the greatest number possible is 17. So next question. So 4 runners started simultaneously at 10 a.m. from a point on circular track. So there is a circular track and 4 runners started from a point P, let's say. So they take, let's say A, B and C, D are 4 runners, and they take 20 minutes, 30 minutes, 36 minutes and 45 minutes to complete the one round. So they are asking at what time they meet all at the starting point for the first time. So after this, at what point they meet, they all meet at the same point for the first time. So for that we need to find out the LCM of all these 4. That will be the time after which they meet together at the first time. And again after the same LCM they will meet again for the second time. Again after the same time they will meet for the third time. So and it will go on like that. So what is the LCM here? 20, 30, 36 and 45. So clearly it is 180. So I can make out, this is simple LCM you can find out, because see here 20 into 9, 30 into 6, 36 into 5, 45 into 4. So 180 is the LCM. So after 180 minutes they will meet again for the first time. So 180 minutes means 3 hours. So 10 a.m., 11 a.m., 12 a.m. and 1 p.m. So they will meet again at 1 p.m. Okay. So the LCM of two numbers is 120. And let's say A and B, the LCM is 120 and HCF is 10. So basically the numbers will be of the form 10x and 10y, where x1 and y are co-primes. Means the only common factor between them is 1. So the LCM is 120. So what are the possible values? So if I take x as 1 and y as 12, so 10 and 120. So for them the obviously HCF is 10 and LCM is 120. So next possibility is if I take x as 2 and y as 12, then 20 and 120, then HCF is 20. So this case is not possible because they have mentioned their HCF is 10. So next case it is, if I take x as 3 and y as 4, so 30, 40. So their HCF is 10 and LCM is obviously 120. So this case is also possible and this case possible. And next if I take x as okay 6, oh it's okay, only then 2 cases are possible. So here what is the sum? Here it is 130, 10 plus 120, and here it is 30 plus 40, the sum is 70. So which of the following can be sum of two numbers? So there is no 130, so 70 can be the sum of two numbers. The next question is, 5 bells ring at an interval of 5 minutes, 6 minutes, 10 minutes, 12 minutes and 15 minutes respectively. So if they ring together at the beginning, how many times they will ring together in 10 hours? Okay. So they are telling they at beginning they all 5 bells rang together. So in 10 hours, how many times they will ring again? So first we need to find the LCM of all this. So that will be the time after which they will ring for the first time. So 5, 6, 10, 12 and 15. So obviously the LCM is 60 minutes, right? So 5, 6, 10, 12, 15, LCM is 60. So every 1 hour the bell rings again. So here the bell rings and after 1 hour it rings second time. So after 2 hours it will ring for the third time. So after 10 hours it will ring for the 11th time. I hope it is clear. I will tell you again. See, there are 5 bells and they started ringing together. And they are asking how many times they will ring together in 10 hours. Like from the beginning till the completion of 10 hours, how many times they will ring together. And they are telling the first bell will ring at an interval of 5 minutes, second is 6, third is 10, 12 and 15, fifth is. So so their LCM is 60. So for every 60 minutes they all ring together for one time. So 60 minutes means 1 hour. So after 1 hour they will ring together again. After 2 hours they will ring together again for third time. Like that, after 10 hours they will ring together for 11th time. When 3738, 5659, 9501 are divided by the greatest possible number x, the remainder in each case is y. Find x plus y. So they are telling basically when these three numbers are divided by the greatest possible number x, so such that the remainder in each case is y. So find the value of x plus y. So for this we have to take two numbers at a time and subtract smaller from bigger. So here you can see 1 2 9 1, and then take these two. Here it is 2 4 3 8, then 9501, and then these two 3738. Here it is 3 6 7 5. So clearly it is 9121. This is 9121 into 2. This is 1921 into 3. This is 1921 into 2, right? So the HCF is clearly the greatest possible number is 1921 here. So when all these three are divided by 1921, the remainder will be the same. So what will be the remainder? 3738 when divided by 1921, it is 1921. The remainder is 7181. So they are asking basically x plus y. So x is the greatest possible number 1921 and remainder is 1817. So 38 37. So 37 will be our answer. So I will explain again. See, basically they are telling there are three numbers which if divided by the greatest possible number x, such that remainder in every case is y. So the remainder is same. To find out the greatest possible number, we are taking two numbers at a time and subtracting the smaller from the bigger. So in the first instance we got 1921, and second it is 3842, and third the difference is 5673. We found out the HCF of these three differences is 1921. So this is the greatest possible number which when divides all these three, the remainder will be the same, y. So I found out the remainder as 1817, and they are asking x plus y. So 1921 plus 1817 is 3738. What is the least value that should be added to 1812 so that to make it divisible by 7, 14 and 11 and 14? So basically they are asking which least number should be added to this so that this is divisible by this. So for this we need to find out the LCM of these three. So 7, 11 and 14. What is the LCM? 14 into 11, right? Because 7 is divisible by 14. So 154. So so that the required number when added to this number should be the multiple of this 154. That is the concept here. Means the least value if added to this 1812, it should be the multiple of this 154. So let's find out some number nearby here. So I think, see, 15 into 12 is 180, right? So let's just multiply it with 12. So 12 4 ja 48, 12 5 ja 60, 64. So 12 1 ja 12, 1848. So what should be added to 1812 to get 1848? 36. So if we add 36, then this number would be multiple of 154. Okay, next question. So a farmer has 945 cows and 2475 sheep. He has 945 cows and 2475 sheep. He farms them into flocks, keeping cows and sheep separate and having same number of animals in each flock. So he wants to divide these animals into flocks and he wants to keep them separated. He doesn't want to mix cows with sheep. So he wants to divide them into flocks, and number of animals in each flock should be same, and he wants to keep the flock as large as possible. So basically he wants to divide the number into flocks of equal number. Means whatever the number of animals in flocks here, cows, should be the same as number of sheep in a flock. So basically what we need to find out is that this number of animals, maximum number of animals in a flock is nothing but HCF of these two. So what can be the HCF? So just see the options. We can see 45, either 45, 46, 9 and 15. So basically both ends with 5. So either it should be 15 or 45. So because out of these two, 45 is more, right? If these two are divisible by 45, then 45 is our HCF obviously. So let's try. So 45 2s are 90 and 45 21. Okay, 0 and 45 2475. 45 45 5s are 225 and 45 5s are 225. So the 45 is his HCF. So the maximum number of animals in each flock would be 45. So how many such flocks will be there? So here so if he divides cows into each flock of 45, then how many flocks will be there? 45 into 21, right? So cows will be 21. And the same if he divides sheep into flocks of 45, how many flocks are possible? 45 into 55. So 55 flocks of sheep. So total 76. So total number of flocks will be 76. So I will explain again. See, basically question states that a farmer has 945 cows and 2475 sheep. He wants to divide cows and sheep into flocks of equal number, and he wants, means the number of cows in a flock should be equal to number of sheep in a flock, and he wants that number to be maximum, which means we need to find the HCF of these two. So we just verified from the options that because the 5 is there, either it should be 15 or 45. I mean, going with common sense. So I tried 45, as anyhow 15 is less than 45, so 45 would be our HCF. So after that, if he divides cows into flocks of 45, then 21 flocks will be there. 45 into 21 is 945. Similarly, 55 flocks of sheep will be there. 45 into 55. So total 76. Okay, next question. So an oil merchant has 3 varieties of oils of volume 432, 534 and 702. So there are 3 varieties of oils, 432, 594 and 702. So he wants to fill these oils separately in cans of equal size, and minimum total number of such cans required. So he wants to fill these oils separately in containers of equal size. Let us say V. So he wants to fill these separately, like don't want to mix, but and also he want to fill in minimum number of containers. So if you want to fill in minimum number of containers, this equal size volume should be higher. So it must be the HCF of all 3. So for this we need to find out the HCF. So let's take 2 at a time and find out the difference. So what is the difference between these two? 594 minus 432. It is 162, right? And these two, 702 minus 594, 801. So 108. Next 702 and 432. It is 07270. So what is the common factor in these 3? So this is 54 into 3. This is 54 into 2. This is 54 into 5. So the equal size, like the can must be of the size of 54 liters. 54. So how many such cans are required? So how many such cans are required? So for A, he should use how many cans? 432 by 54, which is 8. For B, 594 by 54, which is 11. For C, 702 by 54, which is 54 ones are 54, 162 means 53. So total number of containers required 8 plus 11 plus 13. 8 plus 11, 19 plus 13, 32 containers are needed. So let's see this problem again. So basically the problem tells that a merchant has 3 varieties of oil, which is 432 liters of A variety, B 594, C 702, let's say. So he wants to fill them in containers of equal size, and he is asking how many such minimum number of containers are required. So for the minimum number of containers, the volume of the container should be more, such that the number of containers required will be less. So this equal size volume is nothing but HCF of all these, HCF of these three. So I found out the HCF by using two numbers at a time. So that the difference here is 162, difference here is 108, and difference here is 270. So from this we can make out that the HCF is 54, because this is 54 into 3, this is 54 into 2, this is 54 into 5. So if he divides 432 liters into cans of 54, he requires 8 containers. Similarly for B he requires 11, for C he requires 18. So total how many he needs? 32. So with this we have finished the topic of number system and HCF and LCM. So with this the part 1 of this video ends here. So tomorrow the part 2 of the video, which comprises averages, percentage, ratio and clocks, will be released. So thanks for your time and all the best.